night, or as in our case, evening to all attendees, delegates, and invitees of the IEEE Conference on Electronics, Computing, and Communication Technologies, CONNECCT 2021, from Ashwini VR Kholla, your hostess for this session. It's great to see a lot of volunteers from the IEEE family and the academia and industry as well making time for this event that has been hosted virtually for the second time around with a renewed fervor and increased vigor. Extending a warm welcome to all of you on behalf of the IEEE Bangalore section and the Connect team. Happy to have you all here. IEEE Bangalore section, established in 1977, one of the most vibrant and dynamic IEEE sections across the globe, with approximately 10,000 members who are spread across various industries, academia, and research organizations, conduct over 1,000 activities, COVID notwithstanding, with the help of its 126 plus and increasing number of student branches and society chapters and affinity groups. IEEE Bangalore section was awarded the prestigious MGA Outstanding Large Section Award twice and the Art and Distinguished Large Section Award more recently in 2020. Calling on our energetic chair of Bangalore section to kindly address us all, I take this opportunity to introduce Mr. B.S. Bindu Madhava, a scientist, F and Associate Director at the Center for Development of Advanced Computing, CDAC, a part of Ministry of IT, the MeitY of Government of India. He heads the Real-Time Systems and Smart Grid group with around 3 decades of experience in the IT field. Sir is a fellow of Institution of Engineers, an immediate past chairman of IEEE Computer Society, Bangalore chapter, and has been in advisory roles in the executive committee, IEEE Bangalore section for long. Besides being the past chairman of Computer Society of India, past honorary secretary of Advanced Computing and Communication Society, the ACCS, the global member of Internet Society and member Internet Research Task Force. Sir is a man of many interests and currently the chair of IEEE Bangalore section. I request you to kindly address the gathering.
Thank you, Ashwini, for that introduction. Good evening, good afternoon, and good morning. So that's the order because the host being in India and Bangalore. So for all the participants around the globe who are here, first of all, I would like to wish all of us a safe and healthy life ahead. So this is very important. So the other thing what I just wanted to initially say is let's follow all the COVID guidelines and also get vaccinated. So this is another message I thought that using this platform I should start with because IEEE is known for humanitarian activities and this happens to be one of the things. First of all, I would like to introduce the CONECCT. So it is a conference on electronics, computing, and communication technologies. So this was started as a flagship, as an event of Bangalore section and has grown as a flagship event of Bangalore section. So we started in 2013 and this is the 7th edition which we are conducting and out of which 2 are virtual. This is the second virtual conference. And like initially we were chit-chatting, we are able to get all the VIPs who in IEEE for this particular CONECCT conference. So with this particular thing, and also there are 2 pillars who are always involved with this particular CONECCT conference. That is Professor KVS Hari and Professor Debabrata Das. So these are the 2 pillars of CONECCT conference. And of course, Dr. Muralidhara, who is the TPC chair, also is almost connected with all the editions of the conference. So I thought this preamble will put us into a platform where we come to know how this particular CONECCT is available. Anyway, Dr. Muralidhara will give the background of the conference, how the things are scheduled after this one. So we started this year with the mantra of diversity and inclusivity for sustainable growth. So the idea is to make sure that we'll have a sustainability rather than a peak for this particular year alone. So inclusivity is what we were trying to sort of implement. The president's talk always she tells the inclusivity and collaboration. So you can see this particular Connect conference truly inspired by your talk. We have involved all the technical society chapters, all affinity groups of the Bangalore section. So they're all part and parcel of this particular Connect conference, who are the main people who are driving this particular thing. So with that particular thing, I would like to sort of do my welcome address. First of all, I would like to sort of welcome the president, Susan Kathy Land, who actually I just sent a mail and there was a reply saying that, okay, so that will be taken. So all our volunteers were surprised. How can this happen within a short span of time? So I would like to sort of welcome you to this particular Connect inaugural session. And your presence really sort of puts us all in a comfort zone, saying that the president of IEEE supports flagship conference of Bangalore section. So I would like to welcome you on behalf of the Connect organizing committee. And of course, the second email went to Dr. Deepak Mathur. Always, I think this is 6th month which the EXICOM is operating, and almost 6 times he is with us in one way or the other. So every month is getting connected, and virtual has made it like virtual connect is very, very sort of affordable, and sort of keeping in touch also will renew our relationship. So I would like to welcome Art and Director Deepak Mathur ji for this particular Connect inaugural session. So the other person is the India Council Chair, Dr. Suresh Nair. So again, with the written email, we were getting the confirmations. So weekly reviews we used to have. I think within a week, I got the confirmation from all the people to be present in the inaugural thing. So I would like to welcome Suresh Nair for this particular Connect inaugural session. Then subsequently, we would like to sort of welcome all the life member affinity group members, because they are the stalwarts. So I have invited all the life member affinity group members to be present for this inaugural session. So I would like to welcome them. And of course, the Women in Engineering affinity group is mostly driving many of the activities of this Connect. So I would like to welcome all the members of the Women and Engineering affinity group, on all the chairmen and the EXICOM members of the technical society chapters. And I would also like to welcome all the session chairs for this particular inaugural session. For this inaugural session, I would also like to welcome Dr. Shri Arish Mysore, who is the India Office Senior Director, IEEE India Office Senior Director, to this Connect inaugural session. We would also like to extend a warm welcome to all the EXICOM members of the Bangalore section, all the affinity groups, all the subsections of Bangalore section societies who are a part and parcel of this particular Connect. We would also like to extend a warm welcome to all our sponsors, that is the annual sponsor Huawei, Platinum Redisys, and Gold Qualcomm, who are the sponsors for this particular Connect. Last but not the least, we would like to sort of welcome all the press and the media members who are present for this inaugural session. So a warm welcome to one and all present. Thank you.
Many thanks, sir. A round of applause to all the people who contributed to this event from foreground or background. A hearty welcome also to the invited speakers and the keynote speaker. I see in attendance Dr. Gautam Chatubata and Professor Saifur Rahman. Warm welcome to you, sir. Connect has been one of those conferences that has not only gathered considerable footfall and presence over the years, but also seen increased contributions from past authors from all over the world from diverse backgrounds who seek critical reviews requesting Dr. Muralidhara BN, Chair of the Technical Program Committee, CONECCT 2021, to kindly apprise us more regarding the conference.
So good morning, good afternoon, and good evening. The 2021 IEEE Conference on Electronics, Computing and Communication Technologies, that's IEEE Connect, is organized by the IEEE Bangalore section during 9th to 11th of July 2021. This conference is the 7th in the series to be organized by the Bangalore section. This year's conference has received research paper submissions from across 22 tracks. About 230 peer-reviewed papers will be presented in the conference, and these papers will be published in IEEE Explore. These contributions were selected from a total of 585 submissions. We are grateful to all the program committee members of the 22 tracks for their efforts in the review process. We are also thankful to all the reviewers for submitting their reviews in time. Further, we thank all the authors who submitted their work to 2021 IEEE Connect. Unfortunately, due to the ongoing COVID-19 pandemic, holding the conference physically is not feasible. Hence, the conference is being organized as a virtual conference. This should not limit the learning that happens during the conference. The conference began with a set of tutorials in the morning today. Apart from the research paper presentations of about 230 papers in 6 parallel sessions, the conference program features several plenary and invited talks. We request all the participants, especially the student participants, to attend as many talks as possible. We're thankful to plenary and the invited speakers of the conference. We thank Microsoft's conference management tool for the conference management tool used for the submission and the review process. We thank all the volunteers of IEEE Bangalore section for supporting this conference in every possible way. We hope you'll enjoy the technical program of 2021 IEEE Connect and the conference as an informative, inspiring, and a collaborative event. Thank you.
Many thanks to you too, sir. IEEE India Council is akin to a consortia of sections in the Indian geography with collaborative participation by the 12 IEEE sections with around 42,000 members. It's, I think, the largest among the Asia Pacific countries. This is now headed by our next speaker. One often feels very humbled in the presence of people as Dr. Suresh Nair, who is a very accomplished man in the fields of technology and social entrepreneurship. Chair of IEEE India Council for the year 2021, Dr. Nair is presently the Chief Technology Advisor to the Foundation for Innovation and Social Entrepreneurship, an initiative of the Tata Trust. He has also been the recipient of IEEE Outstanding Researcher Award, the DST Lockheed Martin Award 2014, and many more. Without much ado, I call upon IEEE India Council Chair, Dr. Suresh Nair, to kindly address us.
Thank you, Ashwini, for that feel-good intro. Respected dignitaries, Ms. Susan Cathyland, IEEE President, Mr. Deepak Mathur, Director, Arton, my IEEE fellow colleagues, India Council as well as the Bangalore section, Mexican members, plenary and invited speakers and participants, a very good evening. Good morning to you. Thank you for having me in this inaugural function of IEEE Connect 2021. I would like to congratulate the organizers and salute the volunteers of Bangalore section for their untiring efforts to conduct this conference. I think in this pandemic scenario, you have rightly opted for virtual mode for this conference. And it is heartening to note that this is 7th in series, and I wish many more to come. I had gone through the program, and we have eminent galaxy of plenary as well as innovative speakers from across the globe. I think some of them are here today. You have the inaugural address by our own president, Susan Cathyland, who herself is an expert in software. I'm a strong promoter of academia industry collaboration. So there are so many publications here in this international conference. As I see, around 232 peer-reviewed publications out of 585. And I'm sure most of them must have come from academia, most of them. Getting a chance to publish in this conference also talks about the best quality of the publication. So I strongly urge every participant, whether they are students, professors, or whoever it is, you shall not be satisfied with many of the citations of your papers. These publications should get translated into products of social relevance. As engineers, especially as IEEE member or volunteer, it is our responsibility to develop technologies towards humanity. Unless the cycle of basic research followed by applied research, followed by product development by industries happen, we should feel uncomfortable. Basic research as well as major part of the research are funded by tax money. Therefore, we need to take these research into commercial level products so that the same tax money can be created by commercializing these products. That's how the whole cycle works. So I request everyone to look at their publications and the possibility of translating them to commercial products. Once again, greatly appreciate the Bangalore team under Mr. Bildumado and Dr. Muralidhara, and I wish all the very best to the participants. I'm sure you will have the best takeaways from this conference. Thank you very much.
Many thanks, sir. Your observations and comments are noted and shall be reflected upon. Requesting you to kindly accept a memento on behalf of the IEEE Bangalore section and Team Connect.
Thank you. Thank you very much.
Thank you, sir. It's always inspiring to listen to Mr. Deepak Mathur, Director, IEEE Region 10, the Asia Pacifics for this year, 2021. For those who haven't known, the IEEE Region 10 represents the largest and the most diverse geographical area for the IEEE, containing 26 countries with 59 geographical sections consisting of 122,000 members. This is also the fastest growing region in the IEEE with 48,000 student members. Mathurji has served in many leadership roles in IEEE at section, council, region, and member geographic activities. He has been the chair of IEEE India Council and formerly the chief general manager at ONGC, India's premier public sector company engaged in exploration and exploitation of hydrocarbons with more than 35 years of rich professional experience in diverse fields. A recipient of the IEEE Region 10 Outstanding Volunteer Award and the IEEE MGA Achievement Award, Mathurji is also a member of the IEEE HKN or the Eta Kappa Nu, the International Honor Society of the IEEE. Pleased to have you with us, sir. Requesting you to kindly take over the podium.
Thank you, Ashwini. Thank you for such a generous introduction. And good morning, President Kathy and all dignitaries present here and who are virtually attending this conference. In fact, it is a great moment that today we are here for the 7th edition of IEEE Connect, and it is a very good decision of Bangalore section to organize this conference in virtual mode. This we will continue with the organization of virtual conferences. We continue engaging our members and other participants on electronics, computing, and communication technologies through this flagship conference of Bangalore section. So many congratulations to the team Bangalore section for planning this conference, even in this time of uncertainty due to the ongoing pandemic. So on one hand, there are many limitations in virtual formats of events, but we also have many benefits of virtual events. We have experienced better participation in many of our virtual events, and participants are very comfortably joining from the comfort of their own places from different parts of the world. virtual conferences are not only convenient for attendees, but it is also comfortable for speakers to participate from their own places, avoiding travel fatigues, as we were discussing just before the start of the conference. And they can speak in more number of events, benefiting larger audiences. So, but no doubt, we are greatly missing our in-person event and their tangible benefits. But it's good to look at the brighter side of the situation and which we are having today. CONECCT 2021 has an excellent list of invited and plenary speakers. As Dr. Suresh Nair also pointed out, there is a very good mix of speakers from academia and industry, I have noticed, and that is what we always discuss and what we always look for. In Region 10, we have worked on some thrust areas and priorities, and our focus is on diversity, section chapter collaborative programs, conference quality, and industry engagements. And I'm glad to see that all are being taken care of very nicely in CONECCT 2021. So thank you very much, the committee. Team Bangalore section CONECCT 2021 committees led by Bindu Madhavji deserve all appreciation. And I would like to congratulate each one of you for thoughtfully selecting topics, speakers, and organizing this conference. I'm sure participants would be benefited immensely. I strongly feel that we need to have brainstorming sessions with leaders from academia and industry in our conferences, because there is a need to bring industry and academia together so that industry understands about latest research and researchers understand about the requirements of industries. I come from industry background and I strongly feel that our research should mostly be industry driven rather than publication driven, and very nicely explained by Dr. Suresh Nair that we have to take our research to the product. And today in fast changing landscape of technology, increased obsolescence rate in technologies, we should be ready to learn new skill sets. We should be ready to explore new vistas of knowledge, and we need to learn to work in an interdisciplinary environment. That is very important. And now we have also to understand technology from various perspectives, like perspectives of economics, psychology, sociology, public policy. So in today's time, we need to understand technology across all interdisciplinary boundaries, including social implication of technology. And our conferences are the place where we should bring such debates and insights. And I'm sure the CONECCT will address and deliberate on such trending topics also. With this, I would like to conclude and thank once again Bangalore section, CONECCT 2021 committees, and especially my thanks to Dr. Bindu Madhava and Dr. Chandrakanta Kumar for inviting me and giving me an opportunity to share my thoughts. Thank you once again, Ashwini, to you for introducing me, and I wish the CONECCT 2021 a grand success. Thank you.
Many thanks, sir, for your words of inspiration. Please accept a token of appreciation on behalf of Bangalore section and Team CONECCT.
Thank you. Thank you.
Thank you, sir. Bangalore section members and all of us here are really happy to have Ms. Susan Kathy Land with us today, again as our chief guest. Welcoming Ms. Land to CONECCT again, and it's a happy occasion to introduce the IEEE President and CEO of 2021 to our audience. An IEEE Fellow with more than 30 years of industry experience, author, a leader with a vision, Susan has been a diligent volunteer with a long-standing history of service within IEEE. Having served 3 terms on the IEEE Board of Directors as the 2018 Vice President of the IEEE Technical Activities Board, a member of the IEEE USA Board of Directors in 2013 and 2016, a member of the Region 3 Executive Committee 2 times in a row. She has also been the president of IEEE Computer Society in 2009. Happy to have you with us. Over to you, ma'am.
Thank you. Thank you so much. I would like to begin by expressing my most sincere thanks for the kind invitation to speak today at the 7th International Conference on Electronics, Computing, and Communication Technologies, or CONECCT, which is the flagship conference, as you've heard before, of the Bangalore section. And I echo the sentiments of the previous speakers as I applaud the organizers' efforts in putting together this event. Your agenda for the next few days is very impressive, And I've heard that you've already had some pretty impressive workshops, so you're to be congratulated. For those of you who are already IEEE members, thank you. I'm honored to be your colleague. And for those who are not, I hope that attendance at this event can provide you with some insight into what IEEE does, what it can do for you, and what we might be able to accomplish together. So I would encourage you to consider membership. Next slide. So for those who are unfamiliar with IEEE, we are the world's largest technical professional society. Our members are vibrant, diverse engineering and scientific professionals who work across academia, industry, and government, who are committed to elevating their professional image, expanding their global network, connecting with peers locally, and giving back to their community. IEEE's core purpose is to foster technological innovation and excellence for the benefit of humanity. So this vision for IEEE it's to be essential to the global technical community and to technical professionals everywhere. And I know myself and other members of IEEE take this vision very seriously. And we want to be universally recognized for the contributions of technology and of technical professionals in improving global conditions. So you can look across IEEE and see a number of members who are very committed to this, to the vision and mission of IEEE. Next slide. So IEEE, of course, stands for the Institute of Electrical and Electronic Engineers, and the association is chartered under this name, and it's our full legal name. But a number of years ago, it was shortened to just IEEE, and that's because our field of interest covers more than just electronics engineering. It's very broad. It covers everything from broadcast engineers to power engineers, computer engineers. So I encourage you to look at the full field of interest to IEEE to see where you might fit in our wonderful organization. So it brings together engineers, technologists from fields of computer sciences, information technology, physical science, biological and medical science, mathematics, technical communications, education, management, and even law and policy. So it's pretty broad. IEEE's roots go back to the time when electricity and telegraphy began to have a major influence in society with the 1884 founding of the American Institute of Electrical Engineers. And within 30 years, another technical revolution appeared with the birth of radio and vacuum tube electronics. And in 1912, the Institute of Radio Engineers was founded. And on the 1st of January in 1963, which I'm dating myself, but that was the year I was born, the AIEE and IRE came together and merged to form the current IEEE. So today, IEEE reflects 137 years of being at the forefront of the technical revolutions in energy, communications, and computing, underlying disciplines in hardware and software that have supported these technological advances in the many fields of application in industrial activities, consumer products, transportation, medicine, and many other domains that have shaped our modern standard of living. Next slide. So another way to view IEEE membership and activities is through the lens of our technical organization. So today, IEEE's technical activities are organized around 39 technical societies and 7 technical councils, representing the wide range of IEEE's technical interests, and that reflect the broad range of the field of interest that I spoke to earlier. These societies and councils organize our membership around the shared technical interests and bring members together to collaborate in advancing the technical fields. IEEE supports our technical communities with our publication programs, where we currently publish over 200 transactions, journals, and magazines. And we archive and distribute many of these publications through IEEE Explore, which contains over 5 million articles. And researchers download over 15 million articles from Explore every month. That's an amazing thing to think about. IEEE plays a major role in shaping the trajectory of technology through our engagement in international standardization as well. IEEE standards shape the offerings of entire industrial sectors, helping to ensure safety, interoperability, and compatibility with the products and systems used by billions of people around the world. Today, the Standards Association is busier than ever with an active portfolio of over 1,200 standards and more than 900 standards projects under development. And one thing that people might not realize, so I came in through the Standards Association and I participated with IEEE. I was not a member for 3 years. You don't have to be a member to participate in the Standards Association. You can volunteer, you can participate, but you do have to join IEEE and the Standards Association if you want to ballot on the standards that you're working on. But you can participate in working groups and you don't have to join IEEE. That's just a little bit of information. So IEEE also plays a vital role in shaping our profession and our communities through contributions to the larger societal conversation on critical matters through our engagement in informing public policy. Over the last year, the board of directors has adopted new policies that emphasize the criticality of diversity and inclusion and equity in our professions. We are also engaged in global membership in a discussion of the IEEE Code of Professional Ethics. And with that feedback, the board has adopted updates to our code. We have adopted new processes designed to better hold members accountable for the commitment they make to uphold our shared ethical standards. These activities are vital to upholding the trust of the public in our professions and in our members as professionals. In April, we rolled out a completely new ethics and reporting process. Next slide. So today's technologies are merging to create new solutions. Original cross-discipline collaborations are occurring that never have before, and new doors are opening for innovation in most areas of technology. It's a very exciting time. IEEE is uniquely positioned to be on the leading edge of this emerging technology and to provide the organic technical breadth required for these new types of initiatives. Next slide. IEEE technical communities are a growing ecosystem where the diversity of interests, competencies, and needs find a fertile environment for discussion and enrichment. Out of this environment, IEEE membership becomes even more valuable. So IEEE Future Directions is your resource to emerging technologies within IEEE. This is in addition to the societies and councils. The Future Directions Committee continues to identify new technologies as primary focus areas and has established them as formal initiatives to engage IEEE members and volunteers. For each initiative, you'll find a wealth of knowledge, resources, and opportunities that offer opportunities to participate. These initiatives serve to incubate latest innovations via emerging technologies and new applications of current technologies. And it's also a path to identify opportunities to engage the technical community and the general public. So these Future Directions communities work with other IEEE organizations and external partners to focus on emerging technologies through technical, professional, educational activities to serve as a catalyst for new conferences, education, publications, and standards to support new technologies. And if you're interested in participating in Future Directions, you can go to the IEEE website and just do a search for Future Directions. They're always looking for people to participate. Next slide. So here are some of the other opportunities or emerging technologies and related issues involved with Future Directions, and also the direct link if you're interested in looking at more opportunities. So Future Directions was established in 2013, and it's really expanding. It really tries to foster the emerging topics within the societies and councils and to work with the societies and councils. 12 initiatives have graduated so far, and they continue as self-managed communities within the IEEE. And you can see the wide-ranging scopes of interests and issues that have been covered over the years. So I'll provide an overview of 4 of the areas of interest. Next slide. So I'll talk about blockchain. So more than cryptocurrency, blockchain is a technological foundation to a new way of conducting transactions, securing networks, and recording the validity and origin of data. And it's talked about a lot in the press. So we do have a very active working group and a series of technical technical working groups in this area. So blockchain is an open source distributed database using state-of-the-art cryptography through distributed ledger that enables trust among disparate individuals or third parties. And it transforms the way transactions happen on the internet. Every impact in every segment of the impact of every segment on industry and services, it's very hard to calculate the impact of blockchain. So, and it will allow a new perspective of how humans interact to society's challenges, touching on everything from financial transactions, energy trading, carbon emission trading, protection, cyber protection, and easy access to health records, and the protection of valued assets of corporations and nation states. So IEEE launched its blockchain initiative in 2018 to bring together thought leaders, decision makers, and technologists to discuss the challenges and opportunities of this developing platform. And the real thought leaders in the globe are leading on Future Directions blockchain initiative. So if you're interested in this area, you should connect. Participants come from across the range of IEEE's technical interests, including communications, computer science, power and energy, management, reliability, and ethics. So this is very diverse, dynamic, and engaged community for Future Directions. Next slide. So in early 2019, the Future Directions Committee launched IEEE Digital Reality in support of digital transformation. So this initiative serves to enable the coming digital transformation through collaboration among technologists, engineers, regulators, and ethicists. This transformation is fueled by advances in sensors and actuators, artificial intelligence, and machine learning. And it leverages these technologies and others such as augmented reality, virtual reality, and digital twins. The line between the physical world and the digital world will become increasingly less distinct, and that's what this explores. Applications are already quickly emerging in fields of education, manufacturing, shared services, and more. And this is what this area of Future Directions explores. It collaborates with IEEE standards, and it hopes to build mature global standards related to digital reality, augmented reality, virtual reality, human augmentation, and related areas. Next slide. So IEEE Future Networks is dedicated to bringing together researchers, scientists, engineers from industry, academia, and governments around the world to solve the challenges associated with the development and deployment of next generation network infrastructure. So this is a collaborative effort bringing together an interdisciplinary exchange from a wide range of professional expertise and practical application knowledge. And it was launched as the 5G initiative in 2016 and was rebranded to IEEE Future Networks with the tagline enabling 5G and beyond. So it just reflects the IEEE contribution to current and future generations of networking, not being, stuck with one particular deployment of a network. So it's it really recognized the connectivity and applications beyond 5G, recognizing that networking is larger than a single technology, standard, organization, or region. And IEEE Future Networks is gathering the world's researchers, scientists, engineers, and policymakers from industry, academia, and governments to solve the challenges and reveal the opportunities associated with current and future networks. So if you're interested in this area, it's a good community to get engaged with. Next slide. So Ieee Quantum launched in 2019 to serve as IEEE's leading community for all projects and activities on quantum technologies. This initiative has developed as a project plan to address the current landscape of quantum technologies, identifying challenges and opportunities to leverage and collaborate with existing initiatives, engaging the quantum community at large, and sustaining the quantum initiative in the long term. So, and there are many others, if you saw that previous slide. So go check out the Future Directions website and see if there's an area that you might be interested in volunteering in. Next slide. So many of these initiatives participate in IEEE events and conferences and offer a hybrid mix of virtual and in-person events. So you can join the Future Directions at the following events throughout the summer. Here's some other information. So there's, you can see that these are some of the conferences that are also associated. Next slide. So I would encourage you all to get involved with Future Directions. These initiatives are a great way to keep abreast of the developments in emerging fields, and they are open and free to both IEEE and non-IEEE members. Next slide. So before I wrap up today, I'd like to thank you all again for your dedication and perseverance this year. IEEE is an international community that is truly unlike any other. There is no group on the planet that is driving more advances in technology across the widest breadth of fields and disciplines than IEEE. The innovation and implementation of existing and emerging technologies is at the heart of our mission. And our members around the globe are continuously exploring and applying our technology to help solve some of the most challenging problems to improve global conditions. And these are just some of the many reasons why I'm so proud to lead our dynamic organization. And thank you again for the invitation to speak today, and I wish you a successful and dynamic conference. Thank you.
Thank you, Susan. So it's always a pleasure to listen to you. So glad that you could make time for us. Requesting the IEEE President and CEO 2021, Ms. Susan Cathy Land, again to kindly declare this conference as open. Susan?
The conference is open.
Many thanks for that. I feel that this moment needs to be cherished. Can I request all of you to kindly turn on your videos for a group photo? So I request a volunteer kindly take a snapshot. Ketan Advait. We have many more among the attendees. The keynote speakers, Professor Saifer, Professor Gautam. Happy to have you with us. Can you kindly turn your videos on, please? Just a minute more, please. Requesting all of you to kindly turn your videos on. Yes. Did we have that? Okay. Thank you. Ms. Susan, can you kindly accept a token of appreciation on behalf of Bangalore section and Team Connect, a virtual memento?
Thank you so much.
Thank you. At this juncture, we wish to highlight the generosity of spirit and benevolence of three entities: who, despite the pandemic, have reached out to us in support of this cause. Our platinum sponsors, Mrs. Radisys, golden sponsors, Qualcomm, and annual sponsors, Huawei. A round of applause to our sponsors for their patronage. Much obliged. Singapore. Well, feeling of greatness, if not expressed, is like wrapping a present that is not given. So having moved towards the end of the inaugural, as is practice, to place and record thankfulness for bringing together a commendable gathering with a purpose, I call upon Mr. Chandrakanta Kumar, Vice Chair, IEEE Bangalore Section and Organizing Chair of CONECCT 2021. Sir, over to you.
Thank you, Ashwini. Very good evening to all the participants from India and around, and good afternoon to all joining from Europe, and very good morning to all joining from transatlantic region. It's indeed my proud privilege to propose the vote of thanks to this August gathering of technical community, including the top leaderships in the IEEE volunteering chain. Mrs. Susan Cathyland, President and CEO of IEEE, a renowned technocrat in your own field of computer controls and communications, and at present presiding over the largest group of strong technologists through IEEE. But on Bangalore Section Chair's call, you readily accepted our invitation of sharing your thoughts in the inaugurating this conference. It shows the affection that you have for Bangalore Section in general and CONECCT in particular. On behalf of the organizing committee, we express our sincere thanks for being present here and making us feel so special. Thank you, Mrs. Susan. And Deepak Mathurji, in addition to the responsibility that you hold in securing India's energy need, your passion for IEEE is an example by itself. It's always motivating to hear or interact with you in any forum. As art and director, your words means a lot for us. Thank you very much for your time and kind words that you have ushered on Bangalore Section and CONECCT. In India's economic R&D industry, Dr. Nair has made tremendous contribution in realizing products from laboratory. It gives us a lot of confidence that the India Council Chair, as Indian Council Chair, your support is always available to us. Thank you very much, sir, for that and sharing your thought with us today. And Bindu Madhav, sir, as a section chair and general chair, you are the spearhead of this Mahakumbh of Bangalore Section. Still, it is my pleasant duty to thank you on my personal behalf as well as on the behalf of the organizing committee for delivering the welcome address. And Professor V. N. Muralidhara, you are one of the pivots of CONECCT, I should say, and all others move around you in making this successful over the years. Thank you very much for sharing the technical perspective of 7th edition of it. CONECCT has created a legacy over the past few years. Less than 1800 rupees, that is roughly 25 USD for a student member paper, and about 3,500 rupees, that is about 45 USD for a normal member's paper. Of course, some conditions apply. In this endeavor, the sponsors played a big role. And in this context of the year's special circumstances, the support from the Huawei as annual sponsor, ADSS as a platinum sponsor, and Qualcomm as gold sponsor, truly invaluable. A big thanks to all these three organizations. Behind the hand of many volunteers and past leaders are holding the banner of CONECCT together. I sincerely believe no amount of thanks can match their contributions, but as my duty, I thank them in acknowledging their efforts. My profound thanks due to the technical experts, in the form of authors, reviewers, chairs, and speakers. Without you, all this endeavor has no meaning. I also wish that you enrich yourself during these transactions in next couple of days. And we'll assure you that we'll come back to the physical mode in the quickest possible opportunity. I'll stop here for now with a thank you note to Mrs. Ashwini Holla for holding this inaugural ceremony together, and looking forward to see you all in the plenary session following immediately. Thank you, and thank you all.
Thank you, sir, for noting down almost all the people who contributed to the IEEE Connect 2021. On my behalf, please consider a heartfelt thank you. We now conclude the inaugural session for the conference to move on to the plenary session. We have with us 3 plenary talks by stalwart researchers paced at a leisurely pace. Dr. Gautam Chatubata, Jet Propulsion Labs, NASA; Dr. Forrest Schultz, President, IEEE Computer Society; and Dr. Yahya Antar, President, IEEE Antennas and Propagation Society, in quick succession in a few moments from now. Be with us. Thank you.
So now we'll move to the, after the inaugural session getting over, so we'll move to the next technical portion of our day. And that is the most beautiful part of our technical session of the day, that is the plenary sessions. And in this session, as Dr. Ashwini Holla mentioned, we have put together 3 beautiful contributors in the different field of technology. And being this conference as an interdisciplinary conference, and you know that space missions are the most interdisciplinary in nature. And if it involves manned missions, then it includes even philosophy to biomedics and whatnot. You name it, it needs to be addressed. So I now request Dr. Gautam Chatubata to start the first talk. And before that, though I know he doesn't need any introduction for this part of the world, but still it is my pleasant duty to introduce our speaker, Dr. Chatubata. I'll take a few minutes to introduce him formally. Chatubata is a senior scientist at NASA JPL and visiting professor at the Division of Physics, Mathematics and Astronomy at California Institute of Technology, Pasadena, USA. He is a Bell's Distinguished Visiting Professor at IISc Bangalore and Adjunct Professor at IIT Kharagpur. He received the PhD degree in Electrical Engineering from Caltech in the year 2000. He is a fellow of IEEE, IIT India, and also a distinguished lecturer of IEEE. His research interest includes microwave, millimeter wave, and terahertz receiver systems and radars, and development of space instruments for the search of life beyond Earth. He has more than 350 publications in international journals and conferences and holds more than 20 patents. He also received more than 35 NASA Technical Achievement and New Technology Invention Awards. He received the IEEE Region 6 Engineer of the Award in 2018, Distinguished Alumni Award of Indian Institute of Engineering, Science and Technology, India in 2017. He was the recipient of Best Journal Paper Award twice, that is in 2020 as well as 2013 by IEEE Transactions on Terahertz Science and Technology, and this paper award for antenna engineering and applications at UCAP 2017. He is also recipient of Professor Yashan Mitra Memorial Award from IIT. So with these small introductions, I leave the podium over to Dr. Gautam Chatubata. Kindly start your presentation.
Thank you so much, Andakantop. So can I have the privilege of sharing my screen? Okay, I can see that. I am going to go ahead and do that. Let's share. So can you see my screen? All of you?
Yeah, it is coming. And
Okay.
you're audible.
Thank you very much.
Clearly.
Thank you very much. I'm really excited to be here today to this CONNECCT 2021. During the global pandemic, one of the things that actually kept us together and gave us some sense of sanity is this virtual, this connectivity with all of you. Otherwise, I won't be as excited maybe in normal time, waking up at 4:30 a.m. To be amongst with you all. That is if there is any, that is the silver lining of this pandemic, that we are still excited at 4:30 a.m. So let's start this. I'm going to talk to you about, Mars mission, the science, landing, and related technical challenges. So you all know that going to Mars is not easy. My good friend Chandrakanta is here, and many other colleagues from ISRO, they are here. So they all know that, when we go to Mars, we have to overcome a lot of challenges. So what I'm going to do today is trying to, give you some idea that why we go to Mars, what is the science rationale behind that. And because a lot of these questions come up, particularly from countries like India and others, that why should we spend money to go to these places, and to use that funds to do something else on planet Earth? Yes, those are valid questions. However, I'll try to motivate that there is a much bigger picture behind this. So with that, let's get going. So I want to acknowledge my teammates. The team that I work on, there is about 24 people. It's called Sub-Millimeter Wave Advanced Technology. So if you look at the faces of these people, you realize that they come from all over the world. So one of the reason for the success of NASA, in my opinion, is the diversity we have, the diversity of people, diversity of thought that makes us what we are. So it is very important, diversity, equity, and these things are very, very important, and NASA has been playing a great role in that from the beginning. So let's start with this Big Bang. This is the Big Bang theory. This is not the Big Bang theory that you watch on TV. This is a real one. So our universe started with a Big Bang. That's what we believe, the scientists believe. At the current age of the universe is about 13.85 billion years. So if you look at this, how do we know? Because I said 13.85, 2 decimal points, because we know that well. And the first light that came out of this universe is about 380,000 years after Big Bang. We are all, most of us are, have electrical engineering background and electromagnetics. That's what we deal with. So if we want to know about our universe in electromagnetics, then we can go back in time and learn what happened at the beginning of the universe. But only we can go up to about 380,000 years after the Big Bang, not beyond that, because the first light of this universe came out at around 380,000 years. So, but there's other ways to know about what happened before that. But in electromagnetics, we can go up to that. So that is called, the first light that came out is called cosmic microwave background. So it's very important to know that, because we are trying to understand how all of us came about, how this universe happened. Are we alone in this universe? So these are the big questions that we are trying to answer. So as I mentioned, one of the big questions that NASA is trying to answer, and all of us are trying to answer, is, are we really alone in this universe? Is there life beyond our Earth? And for that, a lot of technologies are being developed. If you think about it, this question is asked to me very often, that what is my opinion about this? If you do some back of the envelope calculations, that we have about 100 billion stars in our own galaxy, Milky Way galaxy, and there are about 100 billion, order of magnitude, 100 billion galaxies in the observable universe. And we are finding more and more that most of the stars in our universe, they have planets like our own planet Earth. So far we have, found about 4,000 plus stars, exoplanets they're called, around other stars. So, and we are also finding that majority of these stars, they have not one, multiple planets around them. So if you do your math, you will realize there are trillions and trillions of planets around, in this universe. Then what is the probability that there exists one planet in this universe where conditions are such where life can exist? So if you do the mathematically, the probability is non-zero. And that's what we are trying to find out. Is there any such planets where conditions will be such that life can exist? And we have found, as I said, about 4,000 plus exoplanets so far. The question will be, if I said trillions and trillions of planets, then why only 4,000 plus? Because we have not looked much. If you look at this picture here, let me get my pointer. So if you look at this picture here, that we have looked in our own galaxy, only very narrow areas. The reason is we do not have the technology to really look far and really see those planets, because it's extremely challenging to detect these planets. However, can there be life in really, even if we find a planet that is, conditions are kind of what's called habitable area, what are the ingredients of life that we have to look for? The kind of life that we know today, it needs the hydrocarbon-based life, so that needs water. So we are finding that actually in this universe, there are a lot of water out there. How much water? In one of these stars, they're producing about 100 billion times more than the total amount of water in the Amazon River is produced per second in one of these stars. So in this universe is actually flooded with water. How about our own, solar system? Can there be life in one of those planetary bodies? There are a lot of possibilities. If you see it here, this picture is actually, this is from Enceladus. This one, Enceladus is a small moon of Saturn. And we found from Herschel Space Observatory, I actually built some instruments for that. We found that the water is gushing out from this planetary body. So if there is water, and which means there has to be some kind of source of energy inside that as well. What else is there? Is there any organics? Is there any kind of life in that water in Enceladus? We don't know. We'll have to learn. Another one that I'm showing here is actually Europa. Europa is a moon of Jupiter. And there is an ocean world. Scientists believe there is a thick ice shell and underneath there is water ocean. So what is in there? So that is, we want to know about this. There's also possibility of life on the upper atmosphere of Venus. Venus is a very hot planet, of course, not at the surface, but in the upper atmosphere. So we know that ISRO is planning a mission called Sukrayant. So these are all these possibilities we'll have to understand. We are trying to understand what is going on. Can we find? And for that, we need technology. And Mars plays a big role in that as well. I did not talk about Mars for a reason, because we have been going back to Mars for, India has gone to Mars, the Mangalyaan mission. Why? The reason is Mars resembles Earth in many ways, especially in its early universe. So we want to learn, what happened? Was Mars ever habitable? Was there life on Mars at any point of time? Is there life on Mars today? So this is the big question we want to answer. We want to know as much as possible, and that's why we actually keep going back to Mars. So over the years, NASA has landed quite a few rovers on Mars. Landing on Mars is extremely challenging. Going to Mars as an orbiter itself is a big challenge, and landing something on another planet is, I'll show through this, talk that how challenging this is. You can see that in 1996, we had Pathfinder. There's a very small robot, rover that landed. And then Spirit and Opportunity, the twin rovers in 2003, and the Curiosity 2011, and of course, very recently 2020 was this Perseverance rover, Mars 2020, that landed earlier this year. It was very exciting, and it is an extremely complicated machine, and you can say, okay, very expensive self-driving car. Yes, it's actually has a lot of intelligence in that. It can drive around. It can obstacle avoidance and everything. So, and lot of scientific instruments on them, because what we are trying to find out is that, you know, the region that Perseverance rover landed, there's possibility, if there was life at any point of time on Mars, or there is life, this location, this zero crater where we landed was actually a lake bed, and we are trying to do the scientific experiments. Was there, you know, any sign of life at any point of time? So this is the picture of Perseverance rover that was taken in our lab here at Jet Propulsion Lab before it was packed up and sent to Florida for launch. So this is really exciting. This is a very complicated machine, and I will show a short video. Let's do this to when on February 18th, 2021, when Mars landed.
Perseverance are now closed to subsonic speed, and the detail has been separated. 5 meters ahead further. Or 20 meters off the surface. Have confirmed. Perseverance, safely, the surface of Mars, ready to begin seeking the sound of past life.
So my people around the globe, they heard the voice of my colleague Swati Mohan, and she was the one actually at the helm at the time. So it's very exciting. Every time I see this video, I get goosebumps because it is so exciting. But that is a success story. What went behind that? And that's what we will talk, you know, next 20 or so minutes. So going to Mars, you have to really plan very, very well, because it takes about 7 months to go to Mars. So Perseverance was launched on July 30th, 2020. So we need to have a very big rocket, and then you'll have to cool. When the rover was launched, Perseverance was launched, Mars was here. You can see that, and Mars goes around the sun in a kind of little bit elliptical, but orbit, and we'll have to plan it such a way that it reaches here and catches on Mars at this point, because we have very small window of opportunity to make it happen. So the cruising speed after the launch, the cruising speed of this rover was about 77,000 kilometers per hour. And then it has to arrive just before Mars arrives here. You can see on this one that we arrived at this point just before Mars came, because if we arrive a little late, then we'll never be able to catch up with it. So that's how precise this has to be, all these calculations. And February 18th, we arrived here, and then Mars came, and we were able to enter into the Mars atmosphere. And at that time, the speed of this spacecraft was about 70,000 kilometers per hour. So at this speed, I actually did some calculations. From Bangalore to Los Angeles, where I am right now, it will take about 12.5 minutes to reach. So I wish, we had this kind of technology so that I can go home on a regular basis. But that is not the case. So, and then it has to slow down, right? So that's where the challenge comes. So it is really hard, as I mentioned, this is the hard truth that Mars landings are tough. And we have many countries, we tried a lot, majority of them has been a failure. But we learn from our failure, and that's why you can see that last few missions has been successful. Other than that 2016, it was crashed. Otherwise, from 2003 onward, there will be a lot of success. And recently, you all know that China, Zhurong, they also landed there and has been doing great. So this is amazing. And I'm looking forward to the day when ISRO will also land one of the spacecraft on Mars. That will be really exciting. I'm sure, because we have learned from our last mission to Moon that how to get it done. But we should not lose hope, because if you look at all these different countries, there's a lot of failures. So there is nothing really to feel bad about. So this is the pictorially the same story that in 1970s, there was Mars 3, Viking 1 and 2 landed. Then, as I mentioned, 2003, Pathfinder and Mars Spirit and Opportunity, and then Phoenix, then Curiosity, then in between we landed Insight, and 2020 Mars Perseverance rover. So this is the timeline of these, and of course 2020 was a great year. Again, Zhurong also landed. So about half of all human attempts to land robots on Mars have been more or less in failure. So we have about so far 40% success rate. So it is extremely challenging. But only good thing is that there are last 6 in a string of 6 successful landings on Mars. So we are getting better. We are understanding better how to land there. So these are the different locations that all these the lucky ones that they landed. You can see that we actually choose these areas very carefully, where to land, what kind of experiments to do, so that our knowledge base improves a little bit. So we are, I can see that where the Spirit and Curiosity landed, and where all other where Phoenix landed and where all other rovers landed. So how do we land? What are the technical challenges that I was mentioned? We'll have to be really precise in many things, as I said. So one of the problem of landing on Mars is slowing down the spacecraft, because atmosphere of Mars is about 1% of our own planet, which means there is not enough friction, not enough drag to slow us down. As I mentioned, at the time of entry in the Mars atmosphere, the speed of the vehicle is about 69 to 70,000 kilometers per hour. And then we'll have we have about 7 minutes to slow it down and land since the time of entry. So how do you do that? How do we manage to slow it down from 70,000 kilometers to 0 in 7 minutes? So that is what the challenge is. So one of the things that always done, because of this light atmosphere, you'll have to maximize the path that the spacecraft sees as going down. So we enter the atmosphere at the altitude about 130 kilometers, and it's always at an angle of 11 to 12 degrees, because that gives us the maximum path to at least whatever the light atmosphere it has to slow us down. So entry happens about 130 kilometers, and then it starts slowing down, and then peak deceleration happens at about when we are here. That is, the spacecraft feels 8 to 14 G at that time, because we are really trying to slow us down. And then at the altitude about 8 to 10 kilometers, we deploy a parachute. But at the same time, at the time also, the parachute, the spacecraft is moving at extremely high speed. It has not really slowed down that much. So, deploying a parachute at that speed is not really easy. So we have to really build a parachute that can withstand this kind of speed. For reference, I've shown here Mount Everest, that is about 8.5 kilometer. Here you can see 8.5 kilometer height of Mount Everest. So we are actually deploying the parachute at this location, about 8 to 10 kilometers. And then we use few other techniques. I will show next, what happens. So at the time of the entering, to the Mars atmosphere. I was saying 70,000, we got to 70,000 just before we enter, we slow down. And then at the entry point at 130 kilometer time, when we, above the surface of Mars, we are still in the ballistic, mode where the speed is about 20,000 kilometers per hour. So this is the sequence of landing. So this is cruise stage separation happens, and then this is from where we start counting the time. This is the height of about 130 kilometers that I mentioned, and then it starts slowing down. About this is, you can see here in this cartoon, we have all the time scale about 80 seconds after the entry, what happens, and then at about 10 kilometers from the surface, we deploy the parachute. However, when the spacecraft separates from these, we slow down, but still it has not slowed down as much because the speed at that time is still about 200 miles per hour. So it's still very high speed. So we'll have to deploy some kind of thrusters to slow us down. And then when the height is about about 20 meters or so, we deploy a sky crane. So this is the technology that we used for Curiosity landing. Without that, it will be very difficult because it's a very heavy vehicle. And if we cannot go down with the thruster all the way, because Mars has so much of debris that if we go down further, what will happen? The debris from the ground will come and destroy the spacecraft. So we came up with the idea of a crane technology that lowers the spacecraft onto the ground and it flies away. So that it does not crash on that. So these are the sequences. These are each and every one of them is extremely challenging. And one of the things that Perseverance had that we did not have before is that autonomous detection of the terrain in this. So we have a lot of cameras that were mounted. So we have the lot of pictures from the Mars Reconnaissance Orbiter and other assets that we have on Mars. We took a lot of pictures. And then as the spacecraft is going down, it starts taking pictures and just compares it with where it's supposed to land. Many of you don't know, you all just know the good story that we successfully landed, but as the Perseverance rover was going down, and it was actually going not the place where it's supposed to land, it was going in a different off direction. But because of this technology, it was able to self-correct itself. So our, hearts was in our mouth at that time because, we knew what's going on, but it was able to, compare the terrain with the database it had and made the self-correction and landed at the spot where it wanted to land. So this is an amazing technology, and a lot of people say, yes, do you use AI? Yes, you can call it. This is artificial intelligence in a way because it's self-aware of what is going on. So these technologies had to be built, and that how difficult it is to use new technologies in a space mission. Colleagues who are working in this, they are aware. But this actually worked out really well. So we are very happy that it did the way it went. So another thing that why landing on Mars is challenging, as I mentioned, we'll have to slow down in an atmosphere, a light atmosphere, but the spacecraft is going at such a high speed. So we need to make sure the heat shield that we have on these can withstand all this heat, as well as the structural integrity. So you can see here, the idea is that we'll find the biggest heat shield that we can find that to slow down the spacecraft, but we have to also make sure the mass of the heat shield and area is not too high. Then it becomes prohibitive to do that. So you can see Viking 1 and 2, we use a 1-ton kind of big heat shield here, but Pathfinder is much smaller one. And then for Curiosity and Perseverance, because our rovers are so heavy, so much bigger compared to what we had flown before, we had to use a much bigger heat shield. It's a 2.8 tons it weighs, and much bigger one. But at the same time, there's a lot of innovation has to go in material technology and other aspects and of this. So it is a multidisciplinary effort when you are trying to land something on Mars. So as I mentioned, that one of the reason for going to Mars with this Perseverance rover is to find out was Mars ever habitable. So we chose the location very carefully. The Zero crater, this is the artistic impression of the Zero crater. We believe that there was a lake at the time. Now we have the lake bed, and these places, these areas are fertile ground for life if there was any. And so we want to explore collect samples and see what is going on. You can see here the path that the Perseverance rover is going to take to do experiment. There are a lot of instruments, and also many of you know that there is an instrument called MOXIE on the rover. What it's going to do is, it already has done, it created oxygen from CO2. So in future, if there is there will be astronauts going over there. In that case, they'll be able to use that oxygen, as well as we can use that oxygen as a fuel to actually come back to Earth. Also one of the things that Perseverance rover has done this time is actually doing a sample collection. We have this idea of bringing back samples. You cannot really send all the big instruments to Mars to do your experiments. So what the plan is that Perseverance rover will collect about 40 samples from the Mars surface. And each sample size is about a chalk that we use to write on the board. So chalk size samples will be collected. There are 40 of them. It will put in a container and leave it on the ground. And the next mission that we are planning, so we'll have a rover that will go down and collect all these samples. And then the small rocket, it will launch like a basketball size, a container holding all these small samples in that in space, and then in 2030 2031 time frame, there'll be another mission that will go there and collect that container and bring it back to Earth to do. So this is the first step of Mars sample return mission as well. So these are some of the pictures of landing on Mars, and this time we mounted a lot of cameras and video cameras on the rover as well as on the spacecraft itself that took these pictures. You can see here on the right that this picture was taken by MRO, Mars Reconnaissance Orbiter, as the Perseverance rover was going down, as the parachute was deployed. You can see that picture, and then later on, that from the spacecraft itself, we are able to take a lot of other pictures where everything landed. You can see here where the different things landed. This is the rover with the landing spot, and where the parachute and back shell landed, and where the heat shield landed. So we'll have to make sure that they actually land at different locations. So this is the first time we were able to capture this kind of videos as well as pictures as things are happening. So this is finally, when you saw this picture, it was amazing. This is the first picture that the rover took, looking at the horizon of Mars. And if you actually look at it is no different. It looks so much similar to some of the landscape that we see on our planet Earth. So in that way, it is really Mars is many ways very much like our own planet Earth. So these are a few more pictures. This is amazing picture. You can see all different landscapes. If you look at the landscape on the right side, you see this kind of landscape only when there is some flowing water, which means at some point of time on Mars there's flowing water. So that is very exciting. We are also trying to understand what happened to that water. Where did it go? And can it happen to our own planet as well? So these are the big questions we are trying to answer. So as I said, landing on Mars is not easy because a lot of stuff has to work. It has to work perfectly. We have 3 sets of batteries that has to be perfect. Multiple computers in electronics with more than 100,000 lines of codes. A multi-beam radar, as I said, that the radar actually finds out where we are. What is the altitude of these? All these cameras, the inertial measurement systems. There are 79 explosive devices and guillotine cable cutters, because as the crane lowers the rover to the ground, there has to be cable cutters to cut that so that it can fly away. The motor cannon, thermal tiles, 16 rocket motors. There are deployment devices for the parachute and everything, many more. So each and every one of these has to work perfectly. So that's where the challenge lies. So, and then you all know that I just next take a few minutes next to talk about the Mars helicopter, because I know that I'm running out of time now. So I'll finish up. Chandrakanta, you won't have to worry too much. I'll be finishing soon. So this
No, you have time. Don't worry. Yeah.
Okay. So okay, we'll talk about the Mars helicopter, because that is really, really exciting. That you all know that we have a rotorcraft going on Mars, and actually it's been really, really successful. So we are really happy about it. So why are you so excited about a helicopter on Mars? That is because to fly something on Mars is not easy at all. But what is the idea behind that? Idea behind that if that rover has some limited mobility, it cannot go everywhere. It is not a very fast moving vehicle. We don't want to make a fast moving vehicle as well. So if we have some kind of rotorcraft, you can call it helicopter, you can call it drone, whatever you want to call it, then if it takes off, it's with the rover, and it takes off, and if it has some reconnaissance devices connected to that, it can go around and take pictures and take some data and send that back to the rover, and then the rover can actually decide what are the interesting areas that need to go. So this is the main idea. However, for Ingenuity, it was a tech demo. We wanted to demo the technology demonstration that it can fly on a Martian surface. So there is no science payload on the Ingenuity helicopter. Problem is that Mars, as I mentioned, has the atmosphere is only 1% of Earth's atmosphere. The gravity is 40% of Earth's gravity. The temperature cycle on Mars is minus 90 degree to plus 25 degrees centigrade. Extreme temperature it has to go through. So when we have a helicopter that flies on planet Earth, the rotor blades, it rotates about 400 to 500 RPM, revolution per minute. But since the atmosphere on Mars is just 1% of Earth, to have the enough lift, the rotor blades has to go 2,600 RPM. So this is a huge challenge. So you'll have to design everything, the materials, the blades, everything has to be perfect. So this for normal flights, the idea is to have a 2 to 3 minutes duration. So its maximum range, it has about 600 meters. So we plan it can go up to about 40 meters above the ground and fly. It cannot fly more than 40 meters. The reason is it becomes atmosphere becomes even lighter than you need. Then you won't have enough, the lift that is needed. The rotor blades are about 1.1 meter in diameter. As I mentioned, it's actually 2,600 RPM it moves, and it's very lightweight, 1.4 kilometers, and it has its own power source. It has solar panels. It generates about 220 watts. So it is fully autonomous. So it decides everything on its own using gyroscopes, cameras, altimeter, and all kinds of equipment. And it has telecommunication, which sends the data back to the rover, and the rover sends the data back to Earth. So this is what happened, and this is the picture of the Ingenuity helicopter just before it was final assembly and test on our lab. And this is the first time we tried such a thing. It's really exciting. And then you can see here these pictures that as the rover, it actually removed the shield that was covering. Let me use the pointer again. Interruption. Okay. So you can see here that it removed that shield that was protecting the helicopter, Ingenuity helicopter, and then slowly it lowered the helicopter onto the ground, and you can see 2 legs are deployed here. And then in the next slide, you can see all 4 legs are deployed, and still it is attached at the belly of the Perseverance rover. And on April 3rd, 2021, a few months ago, Ingenuity was released by Perseverance, and this picture was taken by the camera called mast cam that is mounted on top of the Perseverance rover. And you can see on the right this the tracks, the wheel marks of the rover, because it lowered it and then moved away and took this picture of the Ingenuity helicopter. This is the first time we have a rotorcraft that was standing all alone. It's kind of small, you feel really is a vulnerable small aircraft that's sitting there on its own for the first time in the cold night of Mars. And then on April 19th, it took the first flight. It was about 3:34 a.m. Here in Pasadena, California. So that is the time we got the first data, and it took the flight. It went up about 200, about 40 seconds. It did 3 meters. It actually climbed up, and total 40 seconds flight. And this is the real data, the altimeter data that that we got, that it actually went up about, as I said, 3 meters. It hung around for about 40 seconds, and then it came back down. It did some maneuvering. It actually made some rotations. So at that time, the Perseverance rover was about 200 feet away from this helicopter. And see, actually, it turned around about 90 degrees and then actually landed. So I have 2 videos to show you. I end with that. So first video is this. That's the first flight. You can see here the rover is sitting there. And I hope the flight works. You can see the blade started. This is where the rover is. And it took off. It went to about 3 meter height. And it turned around by about 96 degrees. And that took about total 40 seconds flying time. You can see it moved a little bit from its location and then came down onto the ground. That was the first place. That was the first time we flew something on another planet. So that is so exciting. And then the last one is that next slide we have is where you can also hear, for the first time, we have some audio devices. So how it sounds when something is flying on Mars. You can see this is where the helicopter is. You see, it will come back. So just give me a few seconds and it will come back and land again. What you are hearing is the sound of the wind in that area. And then the helicopter returns. There it is. It came back. And it landed again. So this is the first time you could actually hear how it sounds on Mars when you fly something. And with that, I will end my talk. I will open it up for questions. Thank you very much.
What should I say? Thank you, Dr. Chatubata, at these hours for keeping you awake. But I can assure you that it inspires a lot of people when you speak with so much passion and this sort of technology. So that is the return you may be feeling, you may be getting out of this. So it should make you also very happy. Absolutely. And there are many, And there are many questions. I'll take up one or two technical questions and one or two some sort of philosophical questions that I have received. First, technical questions coming to Devdeep is asking, can you please highlight a little bit about the communication systems that is operating between the helicopters?
Yes, so we have a small monopole, you can say a monopole antenna on that, and it sends data at a very low data rate. And because we do not have a lot of power, most of the power goes in for the blades to fly. So what it does is actually send the data, whatever data it collected with the camera and other reconnaissance data, it sends it back to the rover. So this is a short distance, as you saw that the distance between the helicopter and the rover was about 40 meters or so. It's not that much distance, so it can send the data back. And then once the data rover collects all the data, it actually we do not have a direct DTE always to Earth. So there's MRO is there, Mars Reconnaissance Orbiter is there, and Mellon is also there. So what it does is actually send the data to MRO because MRO has much bigger antenna, and then it sends it back. That happens at X band, that deep space network. So that's how we get that's how the communication happens, because it stores the helicopter sends the data to the it stores on its own storage system, sends it to the rover, and rover sends it back.
Okay, thank you. And the next questions, I will take another technical questions. When the helicopter is deployed there, so what is the thermal management system that is being in place for the helicopter to survive there?
Yes. So again, one of the things that I mentioned, the temperature cycle on Mars is minus 90 degrees centigrade to plus 25 degrees. And so that is one of the main challenges, because this is a small body and we cannot really have a lot of thermal management on a small thing. You all know that in space, when you are doing the thermal management, you have to pay always a price of mass. Right? Because how do you, when it gets too hot, how do you radiate heat? And also when it gets too cold, how do you keep it warm? So we have some, thermal in the sense that our heaters to keep it warm. We do not need to make it, cooling system is not really needed because it goes on 25 degrees C, all the components will work. But the main challenge is the motor, so that the motor should still work when it's cold. And so we have some heaters there, and that's what some of the heaters also take some power. So that's how we manage it. But as I mentioned, we cannot do a lot of thermal management for such a small, spacecraft.
Okay, I have just one small query. What is the lifespan of this mission, this helicopter?
Yes, helicopter was supposed to make only 3 to 4, trips. That was when it was planned. However, and so it has been so successful. NASA has now extended the mission duration, and we are trying to break it. So everyone is saying, no, don't try to break it. Why don't you do more? Take more pictures and all. But our idea is to see up to where it can go. When it breaks. So can it go further than what we have planned? Can it go faster than what we have planned? So it is kind of a toy that small kid has, and trying to really drive it as fast as you can, as far as you can. So that's what we are trying. So it has expanded the lifespan, and the mission duration of these has been extended. So it is still going on. We are still doing our experiments with the helicopter.
Okay, thank you. So I'll take one philosophical question. So to end that session, the question is coming as we are thinking that there is a possibility of life in other planet, but if we really encounter a civilization somewhere, so what will be our reaction to that?
That is a very good question. I can tell you my reaction. I'll be excited, because to know. And at the same time, I know it will deflate some of the egos that, we think that we are unique. We are the only one in this universe. We are so great. But that this will prove that that is not the case. So in that way, that will be all mixed feelings, of course. But it is. I know that a lot of people say, okay, why if they come and invade us and all these different kinds of questions are float around. When I give this kind of talk, these questions are asked. But we have, you have to think about it. So far, we found one of the planets which is in the habitable zone that is about 4 light years away. 4 light years sounds small, but it's actually very far. It takes about 40 million years to reach there with our current day technology. So if we are also going to find some civilization, some intelligent life or somewhere else, it is not going to be nearby. So we have not seen any sign yet that in the nearby some kind of advanced life is there. So life has, when you define the life, it could be a single cell life. It could be a very primitive life, but it can be advanced life as well. So I can tell you that I'll be excited, very, very excited if we hear that there does exist life somewhere else.
Yeah, thank you, Gautam Chatubata, for your enlightening talk. It is always nice continue talking about these things, and we'll have different opportunities, I am sure about that. And we'll be coming back to you again and again whenever we have some opportunities. So from the organizers, being a virtual conference, kindly accept a small token of virtual memento that is presented for you. Kindly accept this one.
Thank you. Thank you very much. I really appreciate you inviting me to this forum and giving me the opportunity to talk about something that I am always excited about. Bye.
It's our pleasure.
Thank you, Gautam.
So we had already one exciting talk. All the participants, I think you are already excited. So as I promised in the beginning, we have one stalwart after another. So here comes Dr. Forrest Shull. I think he also doesn't need much of introduction, but as a duty, I should introduce Forrest Shull to the distinguished audience here. So Dr. Forrest Shull, 2021 IEEE Computer Society President and lead for the Defense Software Acquisition Policy Research at Carnegie Mellon University Software Engineering Institute. His role is to lead works with the US Department of Defense and other government agencies, national labs, industry, and academic institutions to advance the use of empirical grounded information to form policy related to software engineering. Currently, he is providing technical leadership into the DoD in support of important initiative to improve the software acquisition. Before joining SEI, he was at Fraunhofer Center for Experimental Software Engineering, where he founded and served as the director for the Measurement and Knowledge Management Division. Since 2015, he has been a member of Computer Society Board of Governors, and since 2016, he served on the executive committee where he helped to institute a metrics-based portfolio review initiative. He has served the society as treasurer, financier of the publication boards, and VP for membership. He received his PhD in 1998 from University of Maryland College Park. He is author of over 100 peer-reviewed publications and co-editor of a handbook on empirical software engineering. So here you can understand his caliber to deliver the plenary speaker, and we have, as we told, we have good mix of people from different area of engineering research. So with this small introduction, the virtual podium is over to you, Dr. Forrest Shull.
Great, thank you so much. First off, let me just say how very happy I am to be here today. Thank you for the invitation. My only regret is that I wasn't able to be there in person thanks to our global pandemic. Yeah, as president of the Computer Society, I mean, one thing that gives me a great deal of pleasure is seeing all the good work from our volunteers, and it keeps me energized. I think it continues to contribute to the vitality of the Computer Society. So I thank the organizers for putting on this wonderful experience and for letting me be a part of it. Let me switch over and make sure I can share my slides here. Okay, does that work?
Yeah, your slides are
Excellent.
visible and you are audible. Yeah, kindly go ahead.
Excellent. Okay, great. So I took a slightly different tack for my keynote this morning, and what I wanted to do was to talk about a different kind of research we've been involved in at my place of employment, to do some mapping and try to project into the future where we're going as a research community in software engineering, at least. And so I know not everyone on the event today is a software engineer, but I think given how softwares tend to be at the center of a lot of the systems we're building, I hope this will be of interest to a lot of folks and thought-provoking. So I'm going to try to get through and then leave a few minutes at the end, at least, for some questions and answers, because I'm very anxious to hear what kind of response we might get. So this is the study, as I mentioned. It's work that we've been leading here at Carnegie Mellon. And what I want to do today is just briefly talk through why we wanted to do this at all. You know, what does it do for us to look into the future of software engineering, and why is that a useful thing? Talk briefly about the methodology of the study, and then, of course, spend most of my time on what we've tried to piece together in terms of a research roadmap for the software engineering field as a whole. The first thing I feel like I have to tell you is why Carnegie Mellon Software Engineering Institute, why we felt like we were the ones that could lead a study like this. And the Software Engineering Institute at Carnegie Mellon sits in a kind of unique place. We're kind of we're what's known as a federally funded research and development center in the United States. And that means we have kind of a special role as technical advisors, if you will, to the US government. So we're not private industry, we're not quite the university, we're not quite government, but we sit in between all those different communities and do our best as subject matter experts to help provide the technical expertise and the strategic direction that the government relies on in making decisions about software and other technical fields. Okay, so our particular role as an FFRDC is focused on engineering and securing software. We've been involved in this since 1984, and we have the mandate from the government to improve the state of the practice for software engineering, as well as associated technical areas such as cybersecurity and AI engineering, which are part and parcel of how we do software today, obviously. The motivation for the study is, again, a lot of reflection and a lot of change going on right now in the United States in terms of government trying to adopt some of these technologies and keep up with where the state of the practice has gone in commercial society. So why we were trying to pull this together and look at where software is going and whether we're able to keep abreast of it or not is based on the recognition that software is vital to our national competitiveness, to the way that innovation gets done, to national security. And as you can see, we've listed other things. It's the underpinning of the economy. I mean, we know it plays a major role in national infrastructure, education, healthcare, and so on. So not to say that that's unique to the US. I mean, I think this is a pattern that we see all around the world at this point, but our remit for the study was to try and get our arms around this for the US government and try to understand what happens there. So while my comments today are going to be very focused on what we're seeing in the US, I would love to have that discussion and say whether or not, hear from you whether or not we're seeing similar trends in our communities around the world. What we were trying to do was to identify future challenges, so understand where we're trying to get to, and what are the challenges that we need to overcome from a technical point of view, so that we can make sure whether or not we have the right manpower, the right resources, the right funding lined up to help us get there. One of the things we felt was that having a roadmap, so even if it's wrong, and it's very hard to predict the future, obviously, but even if we have a slightly off idea of where we're trying to get to, that vision is something that the community can come together on, that we can understand where the challenges are, and we can work together better if we have a vision of where we're trying to get. And so that, looking at all these latest trends and things like intelligent autonomous systems, safety critical, and so on, what are the underlying software engineering principles that go into all those systems, and can we articulate that, and can we make sure that we're doing our best to adapt to that future? The third point, I think, is one that will probably resonate with anyone on the phone or on the video call today who is a software engineer, which is that software tends to be invisible, I think, to a lot of our thinkers, our funders, our system engineers. It doesn't have a very physical presence. It is the part of the system that tends to pull everything else together and provide a lot of capability. Typically, what we see is it's the most adaptable part of the system because change is typically more cost effective to do in the software components than in hardware. And so that drives a lot of the recurring change and the continued evolution that we see in systems. But at the same time, it's something that perhaps some of our decision makers are not as familiar with, and it's hard to visualize. And so it tends to get a little bit left out of some of the calculations, let's say. And so we wanted to see if we could use the study as a way to pull together and get that visibility where it needs to be. And then the fourth one, if I have time today, I'd really like to focus a bit more on this and have some later comments. But I think one thing that we've really been seeing in the US is that to get where we need to go and to get that evolution of the software engineering techniques and practices typically has been a collaboration between industry, academia, and government. But those roles have been really changing for a number of different reasons, which I hope if I have time, I'll get into, and trying to visualize how those entities are going to continue to work together to get us to continue to make advances into the future, I think is one thing that we need to start more of a conversation around. So one thing that we tried to do was to keep our study very much focused on the software engineering principles, how the software gets developed, how it gets tested, how it gets assured, and so on. So we're not particularly looking at what types of systems or types of software we expect to see in the future. But of course, it's very hard to have to talk about engineering practices if you're not having some kind of a vision of what it is that you're engineering, obviously. So on the left part of the slide here, you see some of the visions that we heard from our study participants about the types of systems that we expect to see in the future if we can continue to make progress in software engineering as a field. Obviously, very adaptive systems for defense and other government agencies, systems that perform data fusion at even larger scales than we're able to today, continued highly engineered business enterprises, digital assistants that really assist, so putting a lot more intelligence and autonomy into the systems that are helping us on a day-to-day basis, integrated healthcare, and then things in our kind of common infrastructure that we take for granted, our cities, buildings, roads, having more and more capability, and in fact, somewhat more and more autonomy, again, based on the software that's more and more embedded in them. And on the right-hand side, we try to reflect on what we've seen over the last several years in terms of emerging trends in our software engineering field. So I should say I'm president of the Computer Society this year, but one of my prior volunteer roles was being editor-in-chief of IEEE Software magazine. And so again, that got me very familiar with the need to kind of keep abreast and keep pushing out to the workforce all the latest and greatest, because we are in such a rapidly changing field all the time. So one of the things we used to say on that magazine was that if you're standing still, that is, if you're in the software field and you're not learning, you're not continuing to learn new techniques and keep up with advances, you're really moving backwards, because the field itself is changing. Your competition in terms of other professionals that are out there are changing and evolving as well. And so if you're not continuing to change with it, you're at a real disadvantage in the marketplace. And I think that's one of the a blessing and a curse, if you will, for working in software, is that you're continuing trying to make advances, but at the same time, the field underneath you is changing so rapidly that it adds another level of complexity. So all of which is to say, I think some of the things we've seen there on the right, the second bullet about rapid and assured continuous software evolution. So when I look at some of the things we've seen in software about moving to agile practices, about more recently moving to DevOps or DevSecOps practices, the idea that software capability is expected to be pushed out all the time, and it needs to have at least a good enough level of quality to get out to the users, and we can talk about what good enough means in the context of different systems. But this expectation that capability is continually coming out to me, the systems are not static, the systems are changing rapidly, and our software engineering practices need to keep up with that as a result. One thing that we know from a workforce point of view is that we have gaps today. That is, we can't keep up with the continued high levels of expectations about software quality, about software, how much capability is really out there in terms of software. And that's something that we expect will only get worse in the future. And how do we deal with that is another challenge that we have. I think one theme that I'd like to come back to a couple times, if I have time today, is that second to the last bullet. The idea that in the words of one of our study participants, that we're living in software today. that so much of what we do on a day-to-day basis is controlled by software, is managed by software. We can't do the things that we expect to do as just people in society on a day-to-day basis without the software underneath us. And that has a lot of challenges for us as engineers to keep up with those expectations again. So our approach to the study was to cast the net wide, and on the left there's a list of the resources that we looked at. We did have an advisory board of kind of eminent software figures within the U.S., both industry, government, and academia. We did a number of workshops. We tried to get to as many software researchers and software practitioners as we could to hear what their hot topics were and what their trends were. Obviously, we did our own studies about what technologies were emerging and going up the at various points of the hype scale, getting a lot of hype and publicity at the beginning, and then hopefully settling down to something where we can really make value, understand the value of those technologies. And did our own work on trying to put together scenarios of the future. What do we see as the most likely in terms of where we'll get to go with software? And then our work as the study team was really to take all of that mass of that body of evidence, that body of information, and try and detect themes, do our own affinity grouping, if you will, and try to pull together some of the major themes that we see there that we could fit a lot of that work into to try to make it as actionable and understandable as possible for folks that would want to use that. And then the last step is where we're at now, trying to get these results out so that the software ecosystem can act on the findings, that hopefully this triggers some important and interesting thoughts. And we've tried to do this in a way where we can make some recommendations about what we need to do to better support this kind of engineering that we need to be doing in the future. On this slide, among the dozens of experts that we talked to, I just tried to pull a few names out here just to give you a sense of some of the participants that we talked to. The full list will be in the report, and I didn't mean to leave anybody out or to say that these folks are more important than others. But I just wanted to give you a sense that from the academic and government side, we did talk to National Science Foundation in the US, kind of academic leaders, academic award winners. From industry, we talked to a lot of senior technical fellows and chief engineers, chief scientists, both from small companies that are trying to work in the space as well as larger, the Lockheed Martins, the Amazons. And then finally, because we do sit in our special government role, we did talk to a lot of experts kind of trying to apply software in the government space, specifically in our case in defense, both to build these systems and then to assure the software. And really what I was trying to show here was our motivation going into a lot of the work on this study is that if we could get these stakeholder groups talking to each other, what comes out of the intersection at the middle is these surprising insights that we'd like to see. That is, even as a field, we tend to be a lot more stovepiped, I think, than I would like. And so bringing these different perspectives together and letting them rub up against each other and hear from different perspectives, I think is where we learn the surprising insights maybe about where we need to be going that we're not cognizant of at the moment. So with that as background, let me kind of hit the highlights here of the emerging vision. And again, this is where I would really like to hear any feedback about your own thoughts on this. Trying to pull together all those sources and all those different insights about where software is going. We tried to articulate a very brief, very high level, very thought-provoking idea of what we would expect to see in the future. And so that theme at the top is what we came up with. So the current notion of software development, which is a very manual process, which requires a lot of human creativity and human in the loop and a lot of detailed expertise, will still be there, obviously. But the way in which we will develop software will be one where we can continue to address the challenges of the future in a better way, because we'll have artificial intelligence built into the process, built into the pipeline as a trusted collaborator that can help us build the systems of the future at the scales and at the level of rapid evolution that we need to see. And so some of the reasons that we think that that's a supportable vision are what I've tried to list here on the slide. So we see a number of different advanced development paradigms and how the software gets done, being developed and coming to fruition, based on the trends we've seen as well as where we're going. So we already see in many different fields, AI coming into the picture as a workforce multiplier. We see that kind of across the board in a number of different domains. And the motivating idea here is that we should expect to see that happening in software, just like all the other areas where we're looking at making decisions. We've already, with some of our new advances, like again, DevOps, where I can create these automated pipelines and push as much of the continual monitoring and automation of testing into the regression test suites, into the testing that goes on a daily, a weekly, a monthly basis. We already started to see automation occurring for the more repetitive tasks within software engineering. So we would expect that trend to continue, and that automation can start to incorporate more AI, more thinking, more autonomy to really help us, again, address these issues at scale and to continue to adapt to that high expectation for getting new capability out. Secondly, assurance arguments, and this is an area that we've seen research in for a long time in software. The idea that I can use formal assurance, formal theorem proving, formal modeling to understand the software and to reason about how the components will work together, to make sure that we can assure and efficiently reuse assurance activities and continue to keep up with the rapid pace at which the software itself gets created. Again, we've seen that starting to get more traction in practice now. Again, mostly within specialized areas, again, within the really mission critical, safety critical. NASA, I think, has been one of our trailblazers actually in terms of using these types of formal proofs, formal theorem proving for mission critical software. And as we get more traction with that and more feasibility of applying it in practice, again, we expect that to move out into more areas of software engineering. So those practices will flow into other types of software that gets created. And then thirdly, advanced software composition mechanisms, I should say. So I know a lot of what gets done in software today is reusing basic building blocks. So looking at existing libraries, pulling in components that are able to be reused and that give us kind of the basic functionality so that the software engineers can build on top of that where the creativity is really needed. And again, that's a trend that we only expect to continue to accelerate, especially once you start to put it against some of those other quality assurance things I just talked about. I can now expect to see, within the near future, the ability that I can pick up software components and plug them together as I've done today, that have a higher degree of confidence that they will work together and not have emergent properties or emergent effects that are dangerous for the systems we're building. And at the same time, we have a number of other trends, which are the ones at the bottom, which talk more about how the systems or the types of systems I'll be building, and the types of technologies that come into them to allow us to get where we need to go. The first one, like I said, is this idea that we live in software. That we have to understand that for important classes of the software that we're building today, we need to start bringing in more of the understanding from the behavioral sciences. If I look at things like, at least in the US, I'd say Facebook, Twitter, the very large social media platforms that people are using, they have the humans as the human users as a major component of the system and how the capability gets done. And I think companies, my personal opinion, have been able to exploit some of what we know about human behavior for their own benefit. About what makes behaviors addictive. What is it that keeps people coming back in ways that perhaps we need to start to temper and to do some balance on. So we need to be smarter as engineers about understanding those effects and using them for designing systems for the common good, that behave better as part of the ecosystem that we're part of. Secondly, new analysis and design methods for things like quantum-enabled systems. And quantum, to my mind, is a placeholder, I'd say. I mean, there's a huge amount of research that goes into building these systems, understanding what they're really able to do in terms of what the bounds of the capabilities are, and how to make them usable and assure the quantum software that gets built. And I think that over time, that's just one among many of the new platforms that we'll have to understand and adapt to and bring into the larger systems that we're trying to build. And so I think that the continued work that's there in quantum is for sure important for us and has to be understood as software engineers, how we make these things usable. But that's probably just the first among many new types of paradigms that will push the envelope for what we can do as software engineers. And again, we've talked about bringing AI into the software development process. But we have to reflect at the same time that what we're building are AI-enabled components, so they're part of the outcome as well. And bringing those AI components in where I might not be able to predict their behavior with the same level of fidelity as I can with more traditional software components, understanding how they can interact in more predictable ways, and how that works together to enable us to get to the mission, the societal, and the business goals that we're trying to develop with our software is an area that we've seen work in today, and we expect that to continue to come along. So what I've tried to do on the next two slides is just pull together some of the research that goes into these areas. And again, in the final report, we'll have a much better history of kind of pointing to some of the key research outcomes and the key research enablers that kind of give us confidence that these are the areas that will come along. But I think in the interest of time, I'm just going to kind of quickly go through these. I think I've talked to these mostly already on the last two slides. And what I'll show here, whoop, I didn't realize this was a build. There we go. What we've done here, again, this is more of an exercise in creative thinking, I would say, but trying to predict into the future with our experts across the field, where each of these pathways are going to go into the future. So in the upper right there is our vision of the future, that humans and AI will work together as trustworthy collaborators to build the systems of the future in software. And what we tried to do is lay out for each of those major areas I just talked about, the three advanced development paradigms and the three advanced architectural paradigms, some of the waypoints we expect to see along the way, so that we can detect whether or not we're getting to where we thought we were going to need to go in terms of the work that's going to get done over research in the next several years. And one thing I'd like to point out is that although the chart makes it look like these are discrete and separate roadways, of course, we expect to see a lot of interaction, a lot of collaboration among them. That is, advances in one area will make advances in the others more feasible and more likely as we go. So I won't go into the details of that today. I'll leave that for the final report if folks are interested. And some of the cross-cutting themes I'll hit on here before I end up the talk. Let me just pick and choose a few here in the interest of time. Like I said, number three, I think that what we see today, obviously, is software that gets run and software that knits together very heterogeneous platforms. So even things I do on my phone, the phone itself is only one processor, and that software might go over the network, might rely on calculations that are being done on supercomputers or advanced server farms, and pull that back to the phone so that I get that in my nice little user interface there. So being able to knit together these very disparate platforms is only going to be a problem that gets harder and harder as we go forward. Now think about maybe quantum computing or AI components being part of that network that's working together to get me an answer to something that I've asked for as a query. And so I think one area that we expect we'll need more work on is how I put those heterogeneous systems together with confidence, and expect that they'll continue to work together, even given all the vast different permutations of hardware, software, and networking that's going to have to work together to get me the answer I need. The other one I'd like to really just focus on for a moment is number 4 there, which again, like I said, it's very near and dear to my heart, this idea that we have to be more savvy or more responsible as software engineers about the types of social media platforms we're building, the very large software networks and software capabilities that humans rely on and that are having huge effects in our societies. In the US, for example, we had a lot of controversy and a lot of discussion, which is still going on, about what role social media played, and not only social media, but misinformation and disinformation that was allowed to ride on those platforms in our last several elections. And so I think what we see is that software systems that we went into with huge expectations, about the good capabilities that were going to come out of that, are turning out to play some somewhat pernicious and destabilizing effects at the same time. And so that's where I think that we need to get a better handle on how to build these systems in the right way, how to manage these systems in the right way, to kind of get to a place where they support social interactions rather than have negative effects on it. But I think the larger issue there is that for me as a software engineer, we've all of my software engineering training and a lot of what we do in the computer society, we've talked a lot about abilities. That is, we can talk about functional capabilities with software and how we build systems to address them. But we also have non-functional requirements, things like availability, maintainability, things that are harder to quantify because they are more cross-cutting. And I think that list of abilities that we've always dealt with traditionally as software engineers is going to expand in our near future. I think we've already started to see it today, and we need to develop a better science of these things because expectations of availability, reliability are important, but they're going to be augmented by expectations about things like transparency of our systems, especially where we have big data and algorithms making decisions that impact things in my daily life. Expectations about our system being free from bias. Expectations, especially, I would say, that are led by some of the policy work going on in Europe at the moment about privacy and the way that my personal information gets used in our systems. So software engineering has always, to my mind, been difficult. I think that's what makes it fun. But all those abilities that we've traditionally dealt with are only going to get larger and only going to get harder to quantify. And so we need a lot of research and practice that goes into that to really help address that as an engineering field. And then I'll just briefly touch on number 5. Certainly in the US, one of the things we heard from our academic researchers is that for certain classes of problems, it's very hard to address these within the universities now. If I'm looking at algorithms, if I'm looking at some of these social media aspects and transparency and bias, it's very hard for me as an academic researcher to do things at scale when so much of the groundbreaking work has been done in places like inside Facebook, inside Google, inside Microsoft. They work at scales that the universities can only begin to touch. A lot of the work that gets done is proprietary. And so that's really perturbing the way that university can play a positive role and make some of these advances happen. And so the ecosystem has changed in ways that I think we might need to rebalance or at least be more conscious of. So with that, I will end here because I had a few recommendations here that I wanted to talk about. One thing that we're aiming for is the idea of perhaps some grand challenges in software. What are the really challenging things that we could pose to researchers as problems that we can't do today, but by trying to address them, we can help move the field along, for example. And that's one area where I'd really love to get any kind of feedback, either today or after the session. But I will, like I said, I do want to end here. I tried to pull some of the major thoughts out here on the final slide. The thought that I'll just try to leave you with here before I be quiet and go to questions and answers is that I've tried to talk about this as an engineering field and about the research that needs to get done to support it. But at the end of the day, there's no engineering without a workforce. And so not only do we have these issues to worry about, but understanding how we grow our workforce, how we make it more diverse, how we let more people come in and play a role in the engineering that gets done. And how we take these advances, and I think the computer society has a large role to play in this, but how we take these advances and try to get them out so that they're more usable for people, especially people that are just starting out in the field and coming up and building their own skill sets, continue to be important. And so I think that we'll continue to see some very groundbreaking work and important work there, both within research, within practice, and within our volunteer role here in the computer society. So with that, I've talked a lot. I'd be very happy to see if there's any time for Q&A and respond to some of the audience comments.
Yeah, thank you, Dr. Shell, for this your talk highlighting the future perspective of this development. Of course, there are a few questions. The first questions that I read out is the current level of software abstraction matured enough to create a new language which focuses on creating the abstraction to generate compilable code or directly binary which can run on today's processors?
That's an excellent question. I don't think that we're there today. I mean, I think that and this isn't my field, so I'll speculate based on what I think I've seen though, but I think we've seen some pockets of excellence. And I think specifically within the idea of domain-specific languages, that is, the more specific to a particular type of software or a particular application domain I can be, the more reasonable it becomes to have that level of modeling and that level of fidelity. I think we're not quite there today, for what the questioner was envisioning, but I appreciate the question because I think that is an area that we need to have continued effort on. That level of modeling is going to be important for doing things at scale and with the kind of frequency and speed that our users are demanding. So thank you for the question.
Okay, thank you. The next question is, with the quantum computing being developed, what is the type of change you will expecting in your development of the softwares? Any particular?
Yes, that's a great question. I think the easy answer is speed. I think that what I've seen from the quantum computing, it promises a speed of calculation that is advanced compared to what we have today, and so that's important. But I think there are a lot of issues around things like security, for example. I don't know what it means yet to really secure a quantum system, and so taking some of the areas that we take for granted today in software and start to apply them to this very new paradigm, that's where I think a lot of the research still needs to go. And the other thing I'll say just briefly is that one of the things I think we have to worry about is how we make those systems as usable as possible for developers to use. So it doesn't do as much good as a field to create new quantum computing paradigms that are speedy, that have all this kind of technical benefits. But if we've made them so complex to use that my workforce will not be able to use them, it doesn't advance the field as much as it should. So I think we also have to worry about that side of it, that how we train folks, what kind of expertise and what kind of training is even needed for folks to be effective developers once we get to a real practical computing in quantum.
There is the next question is, generally we see hardware and software development goes hand in hand. So any specific development in hardware is holding the software to unleash its full potential?
That's another excellent question. I'm very pleased with these questions today. I think that's an area that we continue to wrestle with, truthfully. What I've seen today is that what I can do in software, I have such a different cadence in software. I can deliver things almost on a daily basis. And that's very different from the cadence or the frequency at which I can roll out hardware capabilities. So understanding where I can make those divisions, and allow the software to evolve and then have connections back to the hardware is one of the practices that seems to be working today. I think it remains to be seen, what kind of hardware advances might come along that will allow the hardware to adapt and to evolve as rapidly. At least I'll say that what I tend to think of today is looking at hardware systems that can refigure themselves based on the software. So letting the software kind of reconfigure or monitor or adapt the hardware in ways that that explore new capabilities is one area where I look at that. And I have to admit, I don't know enough about the hardware research, to know what kind of hardware specific things might come along from that. But I think that's an interesting avenue to explore.
Yeah. Thank you. And one more last question that maybe you can think of. This is my perspective. So I was just thinking, this conference we organized and we have not printed any hard copy, any single page in that sense. So if you see that previous civilizations we know about from their inscriptions and all these things. So what is your thought about storing our information in a format that will be readable for a future generation, maybe 500 or 1000 years down the line?
Oh, that's excellent, actually. I mean, I do think that getting away from hard copy is important, just because there's so much information now that trying to find an actual hard copy of something is almost impossible, to go back and recalibrate things. So certainly the more that we can digitize, the more that we can make our information available, and I'll connect things to the Computer Society's digital library, for example, or the IEEE's digital library, where I can search and I can find connections I wasn't even aware of. I think that obviously becomes more and more important. In software, we've always struggled with the problem that the format in which that data is represented changes along with everything else in the field. And so I've actually seen this in government projects where we had digital representations of technical information that were critical for the system, which 10 to 15 years on, I can't even read anymore because I've lost the ability to read that configuration or even host the hardware anymore. And that's an area I don't have any good answers, but I will say that that needs to be a subject of research. I think it's an area that we ignore, and we ignore it at our peril. And so I do hope that someone has some smart ideas there about how to do that better.
Yeah, thank you, Dr. Shal, for your interesting perspective on this topic. And with us, Dr. Bindu Madhav is also there, who is the chair of Bangalore section. I'll request him to share his comments.
No, this was a good talk. I think this will be a very informative thing for all our researchers, plus academic people who are trying to look at the future of software development. So agile plus whatever the people are talking. So might be that is the area what we might have to do. Thank you, Dr. Shell, for being here and sharing your wisdom. So it was definitely useful for all of us. Thank you.
Thank you for Dr. Shal and for being a virtual conference. From the organizer's point of view, we wanted to give you a small token of this one in virtual mode. So kindly accept this token from our side.
Thank you very much. Thank you. I'm pleased to be here. Thank you for the invitation again.
Thank you. We'll be getting back to you in our quickest opportunity when we get. And dear participants, we have already two talks in completely different topics. One is the hardware dominated, and the another one is what lies inside the hardware. And there is one more area where it communicates between the hardwares, between two systems that is far apart, that is the communications, and there comes the antennas and all. So our talks are planned in that fashion. So now we have another stalwart in the field of communications and systems and related development in antennas. So we have Professor Ieee M.M. Hunter. He will be talking about the current and future trends in modern antenna systems for communications and sensors. So he is the current president of APS, and he's a fellow of IEEE Engineering Institute of Canada, the Electromagnetic Academy, and URSI. He served as the chair of CNC, URSI, and Commission B. He served as associate editor of many IEEE and IETA journals, and as IEEE APS distinguished lecturer. He has received many international recognition. Actually, I have reduced this one for want of time. The full this one is available in our website. Kindly visit for his accomplishment. But few of them I am reading out. In 2002, he was awarded a Tier 1 Canada Research Chair in Electromagnetics Engineering. In 2003, he was awarded Royal Military College of Canada Excellence in Research Prize and RMCC Class of 1965 Teaching Excellence Award in 2012. He was elected by the URSC to the board as vice president in 2008 and 2014, and by the IEEE APS ADCOM in 2009. He was appointed as member of Canadian Defense Advisory Board in 2011 and in 2012. He received Queen's Diamond Jubilee Medal from Governor General for outstanding contribution to Canada. In 2015, he received RMCC Crown Prize for Excellence in Research. He was a recipient of IEEE APS Cento Dai Distinguished Educator Award in 2007. So with this small introduction, I hand over the virtual podium to Professor Ieee Hunter. Sir, kindly, please.
Thank you very much, Dr. Kumar, and thank you, and thank the Bangalore section for inviting me for this very interesting event. I really value these functions, so thank you all, and I'm really honored to share with you this. And I'll just get my presentation here. So if I Can you see my presentation? Can you see my slides?
It is yet to come up.
Okay, can you see me clearly now?
No, not yet. Your this one is visible, but not the presentations. Can you kindly share it?
Okay. I'm
Chengappa, can you pitch in to help him out?
Yeah, so Professor, you see the share icon next to the video button. So you need to,
yeah, that's what I did.
and then you need to point it out to the presentation that you have opened.
So you see it now?
No.
Okay. Just
It is the virtual background that is coming out. Yeah, yeah, something is coming. Yeah, good.
Okay,
It looks
thank
good.
you. Thank you.
And your voice is also good. Kindly go ahead.
Okay, so I'll just get.
Yeah,
okay.
yeah.
Okay, so thank you very much again. And as you mentioned, I am with the Royal Military College of Canada, Kingston, and my talk today is, you have very interesting talks, and last talk was very interesting. I caught part of it, and I should say that I'm really very pleased about the effort that's going in India, and I'll talk here from the antennas and propagation side of things. So you guys are very active, and since I became president, one of my main priorities was basically to see, make sure that the activities in India are great and so on. So I'll talk a bit about IEEE activities in India, and then I'll talk about the antenna side of things, and I'll try to give you a bit of a general overview where the field of antenna is and how it connects to the other side of communications, and how we see things going in the next few years. And at the same time, I will take the opportunity to talk about the facilities and the advantages of the AP Society, which offers for the young people. I should also mention that I have been to India many times. I work with too many Indian colleagues, and I wish next time I'll be up with you there, but I visit many places in India, and I do quite a bit of research in cooperation with my Indian colleagues, as you're going to see along. This is where I am from, and I can see this is Canada, Kingston, just here on the side of Lake Ontario, US in the background. So it's a small town. And I am in the military college, and this is basically a view of the military college from the water. And Queen's University is right here. So Kingston, if any of you have been to Kingston, is a small town with 2 universities and quite a bit of activities in that. Just take a few moments here to give you an idea about the AP Society. It's one of the 39 societies. It is about 10,000 members. Interestingly enough, out of those 10,000 members, there is over 1,000 in India. And as some of you might know, we are increasing the participation of Indian colleagues in the activities and so on this year. So the society offers many opportunities and has various committees, the site, and the membership activities and so on. And many of your colleagues are actually participating in these committees, and there's quite a bit of things to offer. So I invite you all to get to the antenna propagation site and really see what opportunities in terms of, for example, we have this new committee, COPE committee, which Committee on Promotion of Equality and that offers quite a bit, especially for developing countries. And many of student chapters and so on in India are already involved in that, and that would be good for many aspects of our society. This is a society, as I said, 10,000 members, has quite a bit of facilities, publications, opportunities, and you know, you're all familiar with some of these things. We now offer actually we're going to offer some journals in collaboration with MBTT and other societies, and then the last thing, the open journal and then as propagation. This actually offers quite a bit of seminars and stuff like that. Conferences, and I'm glad to report that just last week we actually technically sponsoring INCAB in India, and it's gonna be hopefully a big conference to get our Indian colleagues to be an active participants in the AB Society. The society offers many activities, and as I said, there is volunteer opportunities. The society is an international society. You know, it is for you, for the members, and it's up to you to participate. And we have created this year new programs. The Younger Professional Committee, for example, headed by C.J. Reddy, who's originally from India. And there are many members from that around the world, including some in India, like Dr. Debdeep Sarkar there, and the other committees, and so on. And also we have colleagues from ISRO, Chinmoy and Jawad, and many others involved in that. So there is volunteer opportunities in that. Now I'll go to the area of antenna, and it's as you might think, to how to do an innovative antenna system. You need to know a bit of the background about electromagnetics. You need to know a bit of microwaves, and this is coming to be more important now, signal processing and antennas involving in new applications, MIMEs and so on. And then obviously after you do all of that, you need to fabricate the antenna. So really, to do a good antenna design for any aspect of communication, you need to be familiar with all of these areas. Maxwell's equation have been with us, and Maxwell was obviously one of the, you know, who pioneered this area, and you can just see from the quotation here how important Maxwell was and what Albert Einstein thought of him. He did basically his work, as you can see here, has produced a transformation of human life. We are all now communicating because of the work he did. Having worked in this area for many decades, I'll just give you an idea how the early days were when we started research in my graduate days, and we're dealing with boundary value problems. Then things changed as we went along, and then numerical methods, commercial software tools, and then new emerging application. One thing I should stress here is with these emerging aspects of communication and so on, it is always need to go back to fundamentals and understand the fundamentals of electromagnetics, and I'll emphasize this as we move on. Well, antennas in real life. So I'll just give you examples of antennas, how they developed over the years. And you can see here from the early days until later on. And then if you look at the cell phones and see where we are now and where we were before, as we move on. With present day smartphones, you actually can do anything now. So the smartphone is, you can do communications, you can do everything. So if you look at how the antennas developed with the cell phones, you had the the early antennas, and as you move on to the cell phone, you can see where the antennas are rolled, and actually we have different configurations of the antennas now, okay, and so on. Well, antennas are used for laptops, and there's always continuous development of that, and you can see some of the developments in that. Now the antennas for the recent Uber, as you can see, and if you look at this aspect here where you actually need the high gain antenna, the orbiter, and then over there you need a low gain antenna to be able to communication. The thing about antennas, you need various antennas for different applications as you move along. So you basically need low or high gain antennas, which is small beam widths, and then you can have antennas that would do all kind of other communications. And if you have a low gain antenna here, because you need to communicate from anywhere. Well, just one of the antennas, I borrowed this from your colleagues there, and you can see the ones for the applications antennas, and then you have antennas for radio astronomy and so on. Antennas for television, and you can see here of for an aircraft what you have in terms of antennas and how many antennas in there. The challenge, of course, here is that you're dealing with too many frequencies, so you have antennas for different frequencies, and these all are being hosted on the plane at the same time. So there's going to be an interesting electromagnetic environment on there. And if you can look at here at the frequencies used, you actually have electromagnetic spectrum almost covered here. So this going from few kilohertz up to several gigahertz. So you can actually see the challenges there on these antennas. Well, antennas obviously are used for security and defense application using active phase arrays, and you can use electronic beam scanning and so on. And many of these application antennas for UIVs and drones, and this is a challenge in how they do it and how for COVID applications and so on. Well, traffic, see cars, there are intelligent, there are many communication aspects in there. And if you look at a modern car, and you can see the various antennas in there in terms of radar applications, in terms of what's involved in that. And that statement is true, that without antennas we will not be able to see or hear what is happening in the world. Then if you look at some of the modern developments, you actually have a MIMO radar antenna on some of these applications. Well, we all know about the Internet of Things and what is happening here, and network devices, many networks, many devices. And if you look at some of these requirements, antennas for Internet of Things, you can actually, these are some of the designs that are antennas, and you see also the antennas for biomedical devices and what is happening there, body-centric antennas for sensors, so on. So if I look at the summary of the antenna applications, we're looking at many applications as we move along, and various type of sensors, of course, and technology, Internet of Things, and biomedical applications, and many more applications. These are putting requirements on the antenna designer, and as well as how the wave propagates. So another aspect of that is also the propagation channels, how to optimize it, and so on. So these are kind of the challenges. If I were a student now, I think this is very rich application areas, and I'll pick up another some of the application areas here and work accordingly. So the field of antennas is actually changing. And as I said, it was the propagation. You just don't do the normal channel, but you can actually work on optimizing the path and optimizing the content, optimizing the channels, and so on. And you can see in the various applications as you for MIMO antennas, propagation channels, and then the intelligent reflecting surfaces where you actually can use, as we're gonna see here, if you look at an example, and I borrowed this from your colleague there. So you can actually use the reflecting surface here to direct the energy in the way you want. And then you can actually also control that surface either electronically and so on. So this is a simple, easy way to control or a new efficient way to communicate. And these reflecting surfaces, you can actually design it and optimize it and go on it. So this is one new area that's coming, and for various applications. Some of these applications were with us before, but with the new techniques, we can actually optimize it, and you can use, as I say, large, two-dimensional array of software controlled scattering elements to direct the channels as you move along. Okay. Well, I'm not going to get into some of these details here, but you can look at see how the electromagnetic aspects, how looking at the various designs, and you can actually use pin diodes to control this reflecting surface and have the channel looking in a different way. So what is the way ahead for research in antennas as we see it, and as we move along? As I said, there is the Internet of Things, and with the Internet of Things, you're gonna use the mobile networks. You basically need to communicate with the satellites and various aspects. So this is a scenario here where you can actually have healthcare, home, business, smart cities, and so on. So this is the way it is going. And what does this mean? Is that you need different antennas for different applications, different sizes, and so on. Well, it's involving the objects, the network infrastructure, and obviously, as we heard earlier, we need computer intelligence to go along with these applications. So the antenna engineer need to be aware of this and aware of things as we go. Here, for example, a typical example or a scenario, what could be in a modern hospital, where you actually have sensors in the room itself. You can have many sensors. You go to the operation, you can have more sensors and then these data and so on. So the design of the sensors, design of the network, and so on. So it is not only an electromagnetic design as we see it, but as we move along, you can see, and also the MIMO aspects, the MIMO channels, and so on. Well, this would give you a bit of challenge in antenna design when you design at a different frequency, and you can see if when you go to a different frequency, the size of the array, and as we move on to higher frequencies, as people talking about using the high frequency range for that. Well, the other area, of course, is if you're doing this and you need to navigate or communicate with the global navigation satellite systems, and these systems are there, and you can actually try to design antennas that work with these things. Well, that is why when I look at that and you ask yourself, where is the areas of research that could be challenging? One of the areas is basically electrical small antennas. Small antennas, as you make the antenna small, there are many challenges in terms of the design of the antenna, in terms of the matching antenna, and so on. We need new fabrication techniques, use 3D printing and so on, and use different materials. Well, phased arrays, there's quite a bit of challenge in the design. Here's circle polarized antenna for wireless power transfer. We're even looking at batteryless wire antenna, batteryless antennas. looking at energy harvesting, how to collect the energy there, and this is going to lead us to those who are working in the antenna field, who are looking at new analysis techniques, basically go beyond just the basic simulation. So we actually need to look back at the fundamentals. When you're talking about arrays and MIMO arrays, mutual coupling is an important aspect. Super directive arrays, and then near field focusing, and more and more problems as we move along. There is in the MIMO aspects, you need various type of, you need the directive aspects of antennas, you need the antenna element interacting as well in the near field. Well, near field is an important aspect of it. Antennas are getting closer. We actually don't know too much about the near field aspects of antennas. We started doing research on that recently, and we're going to have to understand the near field of antennas, as you saw earlier, being placed together or being compact in this crowded electromagnetic environments. And as I said, we need to go into the non-traditional description of the wave propagation phenomena as well. Computational electromagnetics obviously is an essential part of this, and we're using it for this. We're using it for various things, electromagnetic interference, and so on, and so on. And these developments are essential, but at the same time, as I said, you need to keep track of the fundamentals and the interaction and combining these methods to get you what you want, and this is in view of the complexity of the materials and so on as we move along. Now, you really need to be aware, as I said, of the fundamentals of the problems as we move on. And at the same time, you need to look for ways of, analytical ways to get to do some new aspects in that. And one of the new aspects that we did, and this is some work that we did at RMC in collaboration with colleagues from your own place, Bangalore, and other places in India, is something we call the infinitesimal dipole model, and that would look at the, basically looking at the current antennas and having a new look at antennas. I don't want to get into these details here, but the material is available, and what that offers you is actually a new way of engineering the antenna, engineering the current on the antenna to have specific application. So this is a new aspect in the design where you can actually go back. You want to have certain radiation pattern. How would you control the current on the antenna and how you excite it? This is a very interesting area of research, and it actually gives you a better way to find the correlation coefficients for MIMOs and so on, as we reported in the literature. And these are some of the material that we published on that, so you can actually look at that, and you can see some of the workers on this. And this is a book that we have on the fundamentals of electromagnetic, and then this is the some of the faces involved in this process, personnel involved in that. I'm not going to get into the technical details here. I think my time is coming close here. So I want to just leave you with some ideas about where things are going. And you can see the challenge in putting 6, 7 antennas on this here or in this device here, and the challenge that go into it. Another important aspect in antenna research is question of energy. We have had in the literature looking at energy around the antenna and so on, and using some, those of you working on antennas who use some definitions of the quality factor and so on. We have done some research recently, and there is quite a bit going on. And there were issues about the Q factor and how this is an important factor in the design of antennas. And the way it was defined, we're finding that it doesn't really fit with the new aspects of small antennas on the ultra wideband and the new applications. We actually had a new look about that, and there are some issues that we said here, and it involves the excitation of the signal by the division of Q factor, the definition of Q factor based on the fact that antennas are resonant, which they are not most of the time. And then the question of integration. So we always treated antenna as a circuit element, but it's not really a circuit. There are fields around the antenna. And as bodies come close to the antenna, interaction and so on, the field change and the properties of antenna change. So you really need to take this into the design of antennas and look at it in a different way. And this is something that we have to worry about as we move forward. Energy around the antenna, as I said, this is quite a bit of a challenging area. And we just had an article recently about how the antennas, what's involved in the energy around the antenna, and how can you look at the near field to see the far field and the vice versa and so on, and various components and so on. So this is an ongoing research, and we think this would be something that antenna engineers need to look at as we move forward. I go back to the society and the IEEE activities and so on, and I really invite you all to, as those of you who are members of the Antenna Progression Society, to get involved and so on, and those who would like to join the society offer quite a bit of opportunities for education, for learning, for interaction, and with the challenges we have with the COVID and so on. So I really invite you all to join in and be active. And the society is yours; you own it. So please join in, get involved, and you will benefit from that. And I hope again that the conferences in India, initiatives like this, initiatives in the various chapters and so on, continue to grow and reach to us, reach to the Antennas of Progression Society. Like event you're organizing now, Antennas of Progression Society could sponsor it, provide some support in terms of any activities and so on. Not too many people know about these things, but I'm bringing this to your attention now. So as we move forward, you actually benefit from the society and Forge. And I think that gives me, gives you a bit of idea where I'm, what is available there. And if you have any questions about the Antennas and Progression Society or the general areas of antennas, which I didn't want to address here in technical details, please let me know. So again, thank you very much, and I'm really honored to have been part of this, and I look forward to continuous interaction with you all. And finally, as I said, I thank my Indian colleagues, or many of them, for participating and helping us with this. So thank you.
Thank you, Professor Hunter. I also will start from where you started speaking, that you have many collaborators in India. I know Kolkata, then Kerala, and Bangalore. So we are also looking forward to meeting you in some of the occasions physically in near future. And you are always welcome.
I hope I have been to even Kanpur and Patna and Ahmedabad and Kolkata and Kerala and so on, but I haven't been to your part of India. So I'd look forward to that, and that would be a great opportunity to meet all of you there.
Yeah,
thank you.
That will be a real great opportunity for all of us. And I want to mention that here the strength of the Antenna and Propagation Society is more than 100+. And with that, we are very active society. So in that respect, I assure you that we are going to support the cause of AP society at large. And we are continuing this chapter is having a dedicated session for anti-9 propagations in this conference. So in that context, your presence is very much important for us, and it will be very motivating. And coming to some technical queries that has come to me, so I'll just pull out one by one, and few of them I'll ask. With respect to your phased array antenna development, somebody has pointed out, at higher frequencies like Ka band, phased arrays development, like phase shifters and all, how it is placed?
Phase shifters and, sorry, I didn't get the.
Development of phase shifters at higher frequency, like 60 gigahertz, 70 gigahertz.
Oh yes, I have to admit I am not, not too familiar with the phase shifters aspects of it, and I think that question could be some of my colleagues like Gautam and those who are working on the microwave area of things, that they would be able to address this more than I do, because I really haven't done enough work in that. So I have to admit I need help with that. So.
Okay, no problem. I'll get answer maybe from.
I don't know if Gautam is around or not.
No, yeah. So
Okay.
I'll move on to the next questions. That is, one of the participants, he is asking that the practical deployment of 5G systems, how far we are away?
The practical deployment of
5G communication systems, like we in India, we are just listening about that one, that it will be coming in next 1 year or next 2 years, or so. What is the time frame you are seeing that it will be coming in a big way?
Really, again, I'm sorry, but I can't. I'm not. I'm not aware of the recent developments here, but I think I can look into that and get back to you. Yeah.
No, it's okay. It's okay. And then finally, one more, this one. This teaching electromagnetics has always been a challenge. So what are the new techniques do you propose to take for the teachers?
That is a very interesting question, and actually this has been an issue that the Antennas and Propagation Society has been dealing with. And for that, I actually advise the person who asked the question to get into the education committee for the Antennas and Propagation Society, because they actually developed ways of dealing with this, and there are some examples and so on. So if you want, you can check the Antennas and Propagation Society website, education committee, which has 42 members, and some of them actually designed, courses and designed ways on how to approach electromagnetics and so on. It is recognized that electromagnetics is a hard topic to approach it, so there are various ways. There are seminars, there are webinars, and that. So this is one advantage of getting with your colleagues on the Antenna Propagation Society. And as I said, if you want to send me the name of the person offline, I can actually direct him to the chair of the education committee, Carl Warnick, and he will actually provide valuable resources on that, so that you can benefit from that. Yeah.
Thank you, Professor Anter. And with us in the panel, we have the chair of Bangalore section, Dr. Bindu Madhava. So I'll request sir to give your comments on.
Yeah, this was a good and informative talk. Especially, I was interested in the IoT when he was talking about a few slides. I think there's a lot of activities happening on the IoT front, and especially applications like smart cities where IoT is being extensively used. So I think this is a very good information for the people who are in computing and communication, and also embedded space. So I think in total, I think it was a very informative talk. Thanks, Professor. Thank you.
Yeah, thank you very much. And I agree with you. I think electromagnetics is not going to be only electromagnetics. I think communications and electromagnetics are starting to get closer now as we move along with those things. So thank you very much.
And just a thought process, it came to my mind while talking, that when we are talking between you and me, maybe there may be some, at least some maybe 100, not even 100, maybe some 20, 30 antenna is working. So in between the link, so that is how the antenna is all around us and helping us to come out of the wire and all these things. So with this, I thank Professor Anter for your nice talk and giving from the organizer's point of view, we want to offer you a virtual memento for this time. And when you are physically visiting Bangalore, definitely we'll be meeting. So kindly accept this virtual memento from all of us.
Thank you very much again, and I'm really honored to be able to participate in that, and look forward to seeing you hopefully, and more collaboration. And as I emphasized again, please, when you organize this next time, just to get in touch with the Antennas and Propagation Society, because they will be glad to help in this, and I will try to do my best to bring that point, because you have many colleagues in India, and the society would grow more if you guys get involved in that. Thank you.
And thank you very much. So with this three talks from the stalwarts of different aspect of technology and communications, we conclude the today's plenary session, and we call it a day for this conference. And we are looking forward to your participations in same way or even bigger way tomorrow and the day after. So thank you all for joining the event. Take care, and good night to all of you, and see you all tomorrow. Bye for now.
Thank you and good night.
Good night.